ఇంటికి పడగండి.
So Dr. Tagras has joined to coach.
ఎక్కడికి వచ్చింది స్టాఫ్ షేరింగ్ అని?
Not yet, I think. I will contact.
ఓకే. ఎందుకు వెయిటింగ్ సౌండ్ వస్తుంది?
స్మార్ట్ పెట్టాల్సింది.
Hello, time అయింది, జాయిన్ అవ్వాలి. ఓకే ఓకే, థ్యాంక్ యూ. So Dr. Kagras he is joining shortly.
Yeah.
1 or 2 minutes he is joining.
How are you, sir? Professor Samadhiya, sir.
I am fine. How are you? You were not
Fine. Your zero meeting over?
A zero meeting is over, but you were not there in.
Yeah. Yes.
क्या हुआ सर? नाराज तो नहीं हो गए?
No. Already I completed 8 terms. Others can come.
हाँ, नहीं. That is a very good gesture.
Yeah.
But I will keep you busy.
Yes.
I will, because I require help of all the.
Sure, sir. I am there with you always.
Yeah.
Anytime you can call me. I am there.
Yes, sure.
So now, yesterday onwards, you are the president. Day before yesterday.
No. From 1st of January.
First of
January. Okay.
Yeah, correct. First of January.
I am still president-elect.
Yeah.
So Anil is also not there, no?
I am here, sir.
No, in the executive committee.
I am also not there in the executive committee. We will miss the opportunity to be under you, sir, to do that. Be part of you.
And one thing, everybody says that we will be working under Professor Samadhiya.
Working together.
I have a total objection.
Working together.
Everybody will be working with me, not under me. Actually, this is a collective, you can say collective responsibility.
Yes, sir.
And I believe in that collective responsibility rather than this thing like you will okay, I am president, that is another thing, but I will need support of everybody, and I will have to respect the suggestions of all of you.
We are all there with you, sir. We are all there with you.
Actually, Professor Babu and team, they have raised this bar. So we will have to live up to their expectation as well as the expectation of IGS members.
You will definitely do that, sir. You will definitely do that. We are all there to support you.
I will try my level best.
Sir, good morning, sir. Good morning to all of you. So we'll start this session. IGC 2020 Developments in Geotechnical Engineering for Sustainable Tomorrow. Themes 7 and 13. Forensic Geotechnical Engineering and Tunneling and Deep Excavations. Session coordinator myself, Professor M. Ramarao, RVR and JC College of Engineering, Guntur. And chairman, Professor H. N. Ramesh, Bangalore University. Co-chairman, Dr. T. Tyagaraj, IIT Madras. I feel it privileged to introduce the chairman of the session, Dr. H. N. Ramesh. Dr. H. N. Ramesh is presently working as Principal, University Visvesvaraya College of Engineering, formerly Vice Chancellor, acting formerly Dean of Engineering of Bangalore University, Bangalore. He completed BE Civil Engineering from GBDT College of Engineering, Davanagere, in first class with distinction in the year 1984. Obtained PhD from Indian Institute of Science, Bangalore, in the year 1994 in Geotechnical Engineering. He started his career as a lecturer in civil engineering at STJIT Ranebennur in the year 1984. He served as a geotechnical consultant with the Seacon Surveys, Bangalore during 1994-95 and as a senior geotechnical engineer in Tata Consulting Engineers, Bangalore during 95-96. He joined University of Visvesvaraya College of Engineering as a reader in Soil Mechanics and Foundation Engineering in 1996 and was promoted as a Professor of Civil Engineering in February 2004. He was the chairman of Department of Civil Engineering UVCE during 2010-12. Professor Ramesh so far supervised 15 PhD students, more than 70 ME students and 1 MSc Engineering student. He published over 160 research articles in national, international conferences and journals. His publications received Best Research Paper Awards at national level in 1997, 2008 and 2012. He presented technical papers in international conferences at Singapore, Dallas, USA in 2003 and 11 respectively. He has presented papers and chair sessions in many national and international conferences held in India. He also delivered invited and keynote lectures in several national conferences. He served as the chairman of BOE for undergraduate and postgraduate programs in civil engineering of UVCE many times and also as a BOS member for several times and BOS chairman for 2 years. He also had the honor of serving as a BOS member of VTU. Professor Ramesh is actively involved in teaching, research and consulting related to civil engineering. He has handled an AICT funded research project and more than 100 consultancy projects in the area of geotechnical engineering. Presently, he is elected as a member of Executive Council of Indian Geotechnical Society and was the member of Executive Council of Indian Geotechnical Society 7 times previously. He served as the chairman for 2 years, General Secretary of Karnataka Geotechnical Center KGC during 1998 to 2008 and as the vice chairman of KGC during 2008 to 13. He is a member of the expert committees of AICTE, UGC and UPSC. I feel it is a privilege to introduce Professor Tyagaraj also. Dr. T. Tyagaraj is currently a professor at the Department of Civil Engineering, Indian Institute of Technology, Madras. He obtained his BE Civil from Usmania University, Hyderabad and MSc Engineering and PhD from Indian Institute of Science, Bangalore. He worked as an assistant professor at the Department of Civil Engineering, NIT Warangal during 2006-07. He had a brief stint at King Saud University as a research fellow and as an assistant professor during 2008, before moving to IIT Madras as assistant professor in August 2008. He is actively engaged in teaching, research, consultancy, and administration at IIT Madras. His research interests include unsaturated soil behavior, ground improvement, geo-environmental engineering, and the use of waste materials in civil engineering applications. He has supervised 4 doctoral theses, 2 MS theses, and 22 MTech theses. He has published 33 papers in reputed international journals, 3 ASCE geotechnical special publications, 4 book chapters, and 1 edited book. Dr. Tyagarajas received the prestigious Indian Geotechnical Society's Professor Dinesh Mohan Award in 2016 for excellence in geotechnical practices. He has served as editorial board member of International Journal of Geotechnical Engineering. He is an active reviewer for several national and international journals and important conferences and GSPs. He is a qualified NABL accessor for ISO IEC 17025 2017. Dr. Tyagarajas is currently an active executive council member of IGS Chennai chapter and IGS national body.
Okay.
And in this session, 2 theme lectures and 8 contributed papers are there. So now I request Professor H.N. Ramesh to proceed the session.
Good morning to everybody, and I thank Professor Ramarao for his nice introduction. I formally welcome the theme speakers, Dr. Anil Joseph and Dr. Samadhiya, and I thank the organizers for having given me an opportunity to chair this session of Forensic Geotechnical Engineering and Tunneling and Deep Excavations. I also welcome my co-chair, Professor Tyagarajas, IIT Madras, and Professor Sai Annapalli is there. I welcome you, sir. I welcome Professor Mahendra Singh, all the distinguished delegates, ladies and gentlemen. The first theme lecture will be delivered by Dr. Anil Joseph. He is my good friend, and he is an active structural and geotechnical engineer, that is soil foundation, soil structure interaction specialist in India. It is having the current scope. Dr. Anil Joseph has graduated and also done post graduation from NIT Surat, and he was awarded a PhD from NIT Calicut on his work on pre-compression of soft marine clays, and from Open International University on his work, and from Open University on his work on pre-stressing and hollow shell technology in earth. He is the director of Geostructures Private Limited, a leading foundation and structural consultancy firm based at Cochin. He has provided the foundation and structural consultancy for more than 2,000 high-rise structures, including many landmark multi-storied and infrastructure projects in India and abroad in the last 28 years. His design of Nippon Toyota showroom at Kalamassery, then Platinum Mall at Maradu, and Lulu Grand Hyatt Hotel and Convention Center, Bolgatti Island, Kochi has won the ICI Ultratech Award for Outstanding Concrete Structure of Kerala in the building category in the year 2012, 2017, and 2018, respectively. He is the managing director of Seacons Private Limited, a construction firm specialized in the execution of pile foundations, and also the director of um, Engineers Diagnostic Center Private Limited, a firm specified in geotechnical investigation and retrofitting works. He served as the National Executive Committee member of the Indian Geotechnical Society, and for about four terms, and is representing India in the International Technical Committee TCT 220 on field monitoring in geomechanics, and in Asian Technical Committee ASRTC 14 on spot observation methods. He is the member of State Committee in Institution of Engineers Civil Division, Executive Committee member of Institution of Engineers Kochi Local Center, the immediate past president of Association of Structural and Geotechnical Consultants, Kerala, Vice Chairman of Indian Concrete Institute Kochi chapter, immediate past state president of Graduate Association of Civil Engineers, the past president of Association of Piling Specialists, Kerala Honorary Secretary of Indian Geotechnical Society, Kochi chapter, Executive Committee member of Builders Association of India, Cochin chapter, member of Association of Contracting Engineers, Managing Committee member of Kerala Management Association, and adjunct faculty of Albertine Institute of Science and Technology, Cochin. So this shows, the speaker is not only a consultant, he is also an administrator and also is a teacher also. He is an adjunct professor. And Dr. Anil Joseph is also involved in various social activities as vice president of the Regional Sports Center, Kandavantara, Cochin, district secretary of Rotary District 3201, joint secretary of Concure Foundations, etc. He was one among the top 10. This is the recent achievement of this. He was one of the top 10 Diamond Hall of Fame, New Age Icon Change Markets 2020. So it is my privilege to invite the distinguished team speaker, Dr. Anil Joseph. Over to Dr. Anil Joseph.
Thank you, Ramesh sir, for the nice words and the introduction. It's a great pleasure for me, and I would like to thank the organizers. I would like to acknowledge the presence of our incoming National President, Narendra Samadhiya ji, our session coordinator, my close friend Ramarao sir, Tyagraj, the co-chairman of the session, and our one of the main pillar of strength in Geotechnical Society, Dr. H.N. Ramesh, who is the chair of the session, and other my dear fellow participants in the session. It's a privilege.
I think Professor Ramarao, please allow him to be the host.
I think bottom there is a bar. You can use the button now, sir.
Yeah.
No.
And you use entire screen.
Bottom bar is there, sir. Proceed now.
Sir, on the right hand bottom of your screen, you can find present now option, and upside arrow will be there. Yes, sir.
One second.
It has gone again.
Professor Ramarao, how many minutes you will give?
20 minutes, sir.
Okay. Dr. Anil Joseph, 20 minutes.
Yeah.
Put it in the full screen mode, sir. We can see you.
So once again, good morning everyone. Yeah, I will be talking on the theme forensic geotechnical engineering. And I would like to acknowledge my co-authors, Dr. S. Chandragaran, Professor NIT Calicut, and my guru and mentor, Dr. Babuti Jose, Emeritus Professor, Kusat Cochin. So I will be covering my talk in the following heads: the forensic geotechnical engineering, what it is, about the project which I am going to present today, the story before the failure, the collapse of the touch pile system, observations, initial steps taken, review of touch pile design, and we'll come to the conclusion. So forensic civil engineering can be considered to be the investigation of materials, products, structures, or components that fail or do not operate or function as intended, causing personal injury or damage to property. It is an upcoming science that enables engineers to predict the possible failures. It uses the insight to find the causes of failures of the structure and to upscale understanding on how to respond to close calls and to prevent a disaster. With the requirement of service facilities like car parking and the restriction for height of building, construction of deep basement has become a necessity. Structures in the immediate vicinity of excavation, dense traffic scenario, presence of underground obstructions, and utilities have made excavation a difficult task to execute. In this context, analysis and design of deep excavation and their supporting systems are essential. The basic step which should be carried out by design engineers for deep excavations are the site characterization, selecting dimension of excavation, surveying adjacent structures, establishing permissible movements, selecting earth retaining system, selecting supporting and construction scheme, predicting the movements, compare predicted with permissible movements, alter supporting and construction scheme if needed, monitor instrumentation, compare monitored result with predicted and permissible values, alter bracings and constructions. Structural engineers work with engineered materials such as concrete and steel that possess unique and well-defined properties of density, elastic modulus, compressive strength, etc. On the other hand, geotechnical engineers deal with soil, a material made by nature or God with highly variable spatial and temporal properties. Structural designs are code-based since theoretical closed-form solutions are derived based on the given geometry, material properties, and loading. However, geotechnical designs are judgment based upon due to highly variable geometry, complex loading, and material properties that are not precisely determinable, and that's the challenge. And it's words of from the Madhav's literature. A practicing geotechnical engineer cannot provide service without the fear of a lawsuit. Service of geotechnical engineers experienced in geodesic system are commissioned to investigate such failure. Now coming to my problem which I want to share with you today is the touch pile system failure at Cochin, Kerala. So this is the project. It's a B2, B1 basement, ground and 8 floors building. We have parking in the 2 basements and 7th and 8th floor, and commercial floors from basement to ground to 6 floors. And they had a 9.5 meter as the bottom level of B2. So this is the location of the project in Cochin, India. And this is the specific location at the where the work was going on. The touch file system, which was designed by a leading structural engineer based out of Chennai, comprised of 337 piles of 900 mm diameter, extending to a depth of 30 meter depth, and 28 soldier piles of 600 mm diameter to a depth of 30 meter. Building piles were taken to very dense strata at 43 to 46 meter depth. Touch pile system was designed as prop cantilever to resist the lateral load, because once the propping comes, the bending moment and shear force gets reduced considerably and the economy in the design can be brought in. Touch piles were done at boundary by excavating a trench of 900 mm width and 1.5 meter depth in a line and level, and alternate piles were done initially and then in between the piles were done. After completion of shoring work, excavation was done in 3 phases. In the first phase, they excavated up to 2 meter. Second phase went up to 6.5 meter, and the third phase excavation was planned up to 9.5 meter. So this is the video of the site, and here you can see that what was happening. This was on the crucial day of 19th April 2018, when you can see the video which is running. It's the video taken at about 5:36 p.m. And by 7 p.m. there was a slight movement, and the wall has tilted by 20 centimeter. And they were quite worried what to do about that. They called us what has to be done as the local person. So we told that it is better to evacuate the people. And by around 8 o'clock it started moving further, and by 9 o'clock this happened. So that was the video of the failure which was happening, and this is the photos taken after the failure from the adjacent building, and you can see that here the foundation is getting exposed, and this is the after failure photos. And when the excavation, like I pointed out, at 5:30 p.m. the movement happened and 100 deflection increased. Site team sought advice, and we asked to stop the work and evacuate the people. Further shift increased to 200 mm, along with some creaking sound and water jets were noticed on the shoring wall. And by 9:30 p.m., the shoring piles on the southern side came down suddenly. Now, observation after the collapse. Due to collapse of the touch pile system, the nearby road and earth got sunken by approximately 3 meters on the south side of the excavated area. The lateral shifting of the piles near the earth was sunken on the southwest side of the excavated area. Building near the southwest corner had a slight tilt towards the east side and cracks were noted in the building and part of the foundation was exposed. This is indicative of the progressive failure and may lead to sudden collapse of the building. Cracks were noted at ground level in all the other three sides of the excavated area. The roads with pavement of interlocking tiles and differential settlement. The public utilities such as road, traffic, electricity and water supply were adversely affected by the collapse. It also resulted in temporary halt in the working of Kochi Metro since the structure was very close to the metro station at Kalur. So an immediate action plan was made. We were called in, we visited the site and a committee was formed by the District Disaster Management Authority and the job which was entrusted to us was to study the reason of collapse of touch pile system, verification of statutory government approvals, suitability of the touch pile system for further construction and scrutiny of the initial design. So these are the steps which we have taken and since the traffics were affected, we rerouted the public traffic. We refilled the excavated area because we feel that this further collapse is likely to happen and the building in the adjacent area may be affected. So immediately we went for refilling the area. In fact, that same night itself, we have that dredge material out. We pumped in 50 loads of material and there was a second collapse happened at 4 o'clock in the morning. Since we have protected the roads, so it was, we were able to prevent the further damages to the structure. 2-layer sheet piles to prevent further soil sliding was put in. Filling of inner side up to the sheet pile to counter the lateral forces. And for the forensic investigation, we conducted core test, integrity test on pile. And to improve the road, we went for coconut piles because otherwise concrete or any other pile will take long time. And we wanted to re-establish the road and service support systems were also supported using coconut pile. And the stabilization of the road was done with the help of pile. And within 5 days, we were able to get the road restarted. And additional soil investigation was done to study what has gone wrong. So this is the snaps. We have refilled the area by 5 meters to prevent the damage. You can see that here the pile has moved from the top beam which was connecting it. So this is the guiding beam on the top which was stitching together and they are giving instructions to what to do. And this is the metro rail. You can see that which is very close by. And this is the refilling which was done with lateritic soil immediately to balance the thrust so that there won't be further collapse. You can see that the machineries are all submerged below. This is the double, and you can see the drain was here in order to dissipate the pore pressure, and we have a drainage layer here. And the double braced sheet piling was provided, and we went for the concrete core test to ensure that what was the to find out the reason of the collapse. And 11 samples were taken, and 8 from the touch pile and 3 from the tie beam. Pile integrity test was conducted where we have taken the support of one of our co-members in the Indian Geotechnical Society National Committee, Ravigaran Vaidya, who did that for us. And pile integrity test was done on the piles to understand what was the exact point of the failure. And additional soil investigation to confirm the parameters of subsoil strata was carried out. And geotechnical and structural model at different levels was carried out to understand using classic Plaxis and STAT software to find out what was the cause of the failure. So here you can see that the integrity test happening, soil testing happening, the core samples getting recovered, the core test was conducted, and it was found that cube strength values were higher than design value. So that was not the problem. Pile integrity test was done, and we found that the piles has collapsed. In fact, sheared off at a depth of about 14.5 to 15.5 meters from ground level, and length of the standing pile was found to be approximately 30 meters as per the design itself. So this is the data from the pile integrity test, which was carried immediately after the collapse. And this is, you can see that where the damages has been heavily happened. And so this is the length where the strata changes, and the damages is also noted at the points. And this is the additional soil investigation work which was carried out. So you can see that the Cochin comprises of very soft marine clay, and up to 14 to 15 meters there is no much of a support value. And we went for the modeling analysis to carry out the review of the touch pile design. So soil parameters calculation were taken from the geotechnical data, and these were the different components which were taken. This is the pressure diagram, and the capacity of the touch pile was backward. So the dia was 900 mm, M35 was the grade of concrete, what was the steel provided we worked out, and we found that the moment of resistance of the capacity of the pile was 815 kilonewton meter. So that's the one point which I would like to you to note. And then touch piles were checked at different depth of soil retention. That is when the excavation reached 5 meter, what happened? 6 meter, what happened? 7.5 meter, what happened? And when it reached 9.5 meter, what happened? So at 5 meter, we found that maximum deflection 44 mm, maximum overturning moment 350, and we have that MRS 850, so it is safe at an excavation of 5 meter. So 6 meter, it moved, deflection moved to 90 mm. So 633 there, factor of safety still 1.3. Deflection is found to be slightly higher since it's a temporary structure. It seems okay. And once we move to 7.5 meter, maximum deflection moved to 179 mm. Overturning moment across the permissible capacity, not safe. Deflection and overturning movements are higher, and the bracing system of the touch pile has to come into action during this time. So the bracing system has to make it probe to transfer the behavior. So this is the system of bracing system which they have gone in. So you can see the ISMC double section of 1.2 meter beams are provided, and that is the lacing was done by 65 angle, and this is the shoring pile diameter and the soldier pile sizes. So this is the retention modeling. You can see that the three-dimensional model with the spring and the utility ratio just at the brim. So you can see that it is already very close. And when the excavation moved to 9.5 meter, we found that the deflection 400 mm and the movement is much higher than what was capable for the pile to stand. So that is 2090 kilonewton meter, and deflection and overturning moments are higher, and it's not safe. So this is the 9.5 meter strata, and here you can see that the utility ratio just jumping up to the range of 3.55, 3.7, indicating inadequacy of the bracing system to take care of the loading which is going to come. Since there is failure in truss element, deflection and overturning moments were also much higher. So the analysis result summary, finding from the analysis are: the shore pile with single strut propping system used in this project is found inadequate to take the lateral forces for the proposed depth of excavation of 9.5 meter. The reinforcement of the shoring pile is found inadequate against bending with single strut propping system at top provided for the proposed depth of excavation of 9.5 meter. For excavation carried out up to 6 meter depth, the touch pile system comprising of 90 centimeter diameter piles without strutting was adequate. When depth reaches 7.5 meter, the strutting system was found to have marginal deficiency to take up the earth pressure, and it was found that for the depth of 10 meter, the provided touch piling system and strutting was grossly inadequate to take up the lateral thrust. The strutting system used was a series of truss beams in grid pattern, but not orthogonal to each other. This will have a tendency to make the grid system skewed and to facilitate further yielding of the probes. Soil at current depth of excavation has turned very soft on account of water seepage. This has caused considerable weakness of the interface soil. High thrust from the shoring pile at the interface has caused yielding of this soil. Subsequent increase in unsupported length of the pile is also a reason for the failure of piling bending. So as per the analysis, inadequate strut system, soft soil, yielding of soil, high thrust from shoring pile, increase in unsupported length of pile. A second tier of strut system at a lower depth could have been helpful in retaining the touch pile system in position. So this was the suggestions of the technical committee. The team scrutinized all the approval documents needed for the project, and they were found in order. If adequate bracing system with higher sections and proper balanced geometry is adopted, the present touch pile system installed can take up the lateral earth pressure due to the excavation up to the proposed depth of 9.5 meter. Diagonal cross bracing, especially as owners, have to be provided. That always we have to remember when we go for deep excavation to bring in the required rigidity. That is the most vulnerable point. It is also suggested that the setback of the building of the touch pile system near the road be increased by additional 4 meters so that the road and the public utility system remain unaffected. The committee felt that the collapse of touch pile system of the building should serve as a wake-up call to the authorities and the engineers in the construction industry. It is only sheer luck and timely intervention that there was no loss of human life. There was only one building close by, and it has to be dismantled now with workers in the excavated area, and with buildings close by, it would have been not just a failure but a catastrophe. So the conclusions to be drawn: accurate cost analysis or work study is difficult to carry out for there is limited commonality to make comparison. Every project, though looks relatively similar from certain indicative factors, it is in fact unique in itself. A great number of random and uncontrollable variables are likely to arise during the course of work. This makes planning and scheduling difficult and our profession very interesting. The actual effectiveness of work is highly dependent on the as constructed site environments, quality of the management and the executive parties, as well as the problem solving ability of the frontline persons also seriously affect the performance and effectiveness of work. Dynamic layout arrangement is usually required for the removal of the exploited soil from the basement. This may involve forming of temporary ramp, provision of special equipment, or taking over of part of the completed building as temporary access. And thank you very much for your patient hearing.
Thank you, sir, for maintaining time. Uh, and it's the forensic study is the hard field, and as usual, you have given a new topic in the conference. Thank you very much. Before the co-chairman, Professor, um, our co-chair give the summary of that, I invite one or two questions, if any. Professor Tagraj will summarize once the question and answer session is over. I invite one or two questions. Any questions or clarifications? You can unmute and ask questions. Anybody? Please raise your hand. That option is also there. Okay, if there are no questions.
There is one question from Anil Cherian in the chat box. Why there was no precondition survey and the initial pile testing performed to verify the design?
Yeah. Thank you, Anil, for the question. In fact, it was they have done lot test for the tower pile. They have done the initial lot test as well as routine lot test for the tower pile. But for the pile which has to be the touch pile system, part of the touch pile system, it is very difficult to conduct the lateral loading because we are removing the foil there, and the pressure will happen as we excavate down. So even though the initial test was done for the main pile, it was not possible for the touch pile system. So that is why it was not done.
Okay, thank you, Anil Cherian. Any other questions? No other questions in the chat box. So I request now Professor Tagraj, co-chairman, to summarize briefly.
Thank you, Chairman. Very nice. You all agree with me that it's a very good presentation by Dr. Anil Joseph, especially on the forensic study. It's very limited studies are there on this topic. It's very interesting, mainly on the earth returning structure. He brought out very nicely how it has failed, and the lesson learned also he has explained very nicely. And especially whenever we have the trust system, it should be orthogonal to each other. This type of things he brought out very nicely, the lacuna in the initial design and all that. Thank you very much, Dr. Anil Joseph, for bringing out this topic.
Thank you, Professor Tagraj. Thank you, Professor.
Thank you, Professor Tagraj, and I once again thank Anil Joseph for having delivered the excellent theme lecture in forensic geotechnical engineering. Now the second theme speaker is Professor N.K. Samadia. Professor N.K. Samadia is the president-elect of the Indian Geotechnical Society, and I know him personally over 2 decades, and many of the conferences we met and we served each other as the executive committee member of Indian Geotechnical Society. In my personal observation, he is very cool-headed, hardworking, committed, and dedicated about the IGS works. And Professor Samadia is at present the professor in the Department of Civil Engineering, IIT Roorkee. Previously, it was University of Roorkee, and he is the recipient of IGS Professor Leonard Biennial Prize 1999-2000 for the best PhD thesis in the geotechnical engineering. He has published several IGS. He got several IGS Best Paper Awards and ISR MTT Best Research Award. The research papers numbering over 200 have been published in national and international journals and conferences. and he has organized many conferences and workshops under the aegis of Indian Geotechnical Society. To name a few, on Indian Geotechnical Conferences IGC 2003 and IGC 2013, he was organized. He is the chairman of BIS CED 48 Rock Mechanics Committee and an active member of TC 207 Task Force of ISSM NGE on preparation of the guidelines on soil structure interaction and retaining walls. And now, next 2 years from January 1st to 2021 to December 31st, 2022, he'll be heading IGS, and under his guidance and leadership, number of conferences will be held, and at least two IGCs will be held, and he is going to handle all these things. Already he is having, as he himself has organized two IGCs. He is the most experienced person in IGS and also the senior professor of IT Roorkee. Sir, I invite you to deliver the lecture on the development in geotechnical engineering for sustainable tomorrow. Thank you.
Thank you, Mr. Ramesh, for the nice words. And at the outset, I would like to thank the organizers for giving me this opportunity. Dr. Tyagraj and Dr. Ramarao. So I will be presenting my lecture. So I will just share. There is some problem, I think. Okay.
We were able to see your screen, sir. We were able to see your screen.
Yeah.
One more time, you can share it.
Present now. Enter screen. Then
Sir, now your screen is being presented, sir.
Yes, sir. Now you can go to the PPT, sir. Now you can go to the PPT, sir. We are able to. Yes, sir. We can see your screen.
okay.
Presentation mode, you can see.
Now can you see full screen?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So thank you very much. The today's lecture is analysis of shortcrete lining and the estimation of support pressure of Sardar Sarovar underground power cavern. Actually, what I have tried to find out the support pressure based on the analysis of the shortcrete. So it is actually the shortcrete has been analyzed, and I have used one layer of joint element on the top of the shortcrete, which is in contact with the rock mass. So initially I have analyzed the Sardar Sarovar Paho's cavity, and finally whatever displacements were obtained, those displacements I have considered as the boundary condition for the joint element, and whatever normal stresses I have got on the shortcrete lining, those I have termed as the support pressure. So for any underground excavation, the design and performance evaluation, it warrants the knowledge of displacements and the stresses in the surrounding rock due to excavation. Now, as you know that in situ rock will always have discontinuities in the form of various geological structures. So these play a dominant role, and they influence the displacements and the stresses in the surrounding rock after the excavation. So the analysis of underground openings should be systematic and scientific. If it is not, then you will get this type of situation, it may collapse also. So this is the heading collapse, 27th of October 2004 in Teesta Powerhouse project. Now, as I said, that the rock mass essentially consists of two constituents. One is the intact rock, another is the discontinuities. So the presence of these natural discontinuities, which may be part of a fault or a fold or a shear zone or joint or bedding plane, these can exert a significant influence on the response of rock masses in both surface as well as the underground excavations. So all these joints always occur in sets. These create anisotropy in the response to the applied stress field. So in order to analyze this Sardar Sarovar Powerhouse cavern, I have used the shear zone as well as the rock mass, all the joints, their orientation, their actual attitude, means dip and dip direction, their spacing, and the number of joints, etc. So for that, I had to develop a 3D joint interface element, and this is the 3D joint interface curve element, in which, since I have done the three-dimensional analysis, so I have gone for the 16-noded joint interface element. So the top surface will be in contact with the different material, and the bottom surface will be in contact with the different material. So as far as the derivation is concerned, so this is the middle surface of the joint element interface. I will not be going in the details of this because all these details are available in my ASC paper, International Journal of Geomechanics. So what I have done, I have determined the relative displacement between the top surface and the bottom surface, and from that I have tried to find out the D matrix for this particular joint element. So all these details are available in this paper 2008, 3D joint interface element for rough undulating major discontinuities and rock masses, International Journal of Geomechanics, ASCE. So this is how I have got the element stiffness matrix for the joint element. And similarly, since I have got the regular jointing in the rock mass, so I had to derive the constitutive relations for the rock mass. So what I have done, I have taken the overall response of the rock mass and tried to replace it by another anisotropic continuum, so that I can get the response of the entire rock mass. So here, this epsilon z double dash, these are the strains in a direction perpendicular to the joint, and there are number of joints, so I have summed up. I have also tried to take into account the dilatancy which is occurring to the change in volume or the overriding of the joints during sliding. So I have tried to find out the strain displacement matrix, that is the also known as the compliance matrix. And since there are joints oriented in different directions, so there will be different directions involved. So I had to go for the transformation matrix from one axis system to another axis system, and another axis system to the axis system perpendicular to the joint. So here, this is the compliance matrix for the rock material, and this is the compliance matrix for the joint. So again, this particular part is also published in International Journal of Geomechanics, ASCE. So I will not be going in the details. Now, including all those features, I have developed a program. Actually, I wanted to name it as ASRAM, but I could not do it. So this is ASARM, that is the analysis of stresses in anisotropic rock masses. And there are capabilities of this particular program. So here, this is our program at IIT Roorkee, and we have analyzed several cavities using this particular program also. So this program is a general purpose finite element program, and program structure is modular, application in rock and soil mechanics. This is displacement formulation, and three-dimensional solid element and 3D joint element can be included. It can take into account the dilatant behavior. We have done no tension analysis. It can be used for isotropic and isotropic, and the explicit representation of major discontinuities and implicit incorporation of the regular jointing. Pressure dependent modulus has been used. Now I have extended it for the water charged rock mass also, and we can go for multiple loading condition. So again, the entire description is given in one of my paper of Journal of Rock Mechanics and Tunneling Technology. Then using this program, I have analyzed the Sardar Sarovar powerhouse cavern and tried to find out the stress distribution and also the displacement. And those displacement I have used as the boundary condition for the analysis of the shortcrete lining. All the details are again given in International Journal of Rock Mechanics and Mining Sciences. So coming to the, with this background, coming to the Sardar Sarovar powerhouse project, it is a World Bank aided multi-purpose river valley project, which all of you know that it is constructed on river Narmada and is situated at Kevadia village in Gujarat state. Now this project includes 138.68 meter high and 1210 meter long concrete gravity dam, the underground powerhouse cavern, which is aligned north 10 degree east parallel to the main dam, is a large cavern of 23 meter width and 210 meter length and 58 meter height. And this cavern, the overburden is of the order of 30 to 65 meter, and there are various types of rock, like we actually have the agglomerate, the dolerite dikes. Those are ranging in thickness from 40 to 55 meter. And one such dike, which cuts the alignment from channels 1448 to 1492.5 meter at the cavern X, is aligned in north 70 degree east, south 70 degree west direction, and dips at 60 to 65 degree towards the river side. So both contacts of this dike with the adjoining basalt flows are sheared. The first shear contact is thin and does not intersect the cavern, whereas the second shear contact, that is shear zone B, I have designated it as shear zone B, is 1 to 2 meter wide and intersect the cavern at channels 1492. So this is the geological longitudinal section. Now you can see here, these are different type of rocks which are there. You have agglomerate, you have the basalt, you have the dolerite dike, and you have the dolerite sill. Now this dolerite intrusion is something like this, and there is another dike, vertical dike on this side, but it doesn't intersect. So this is the boundary of the cavern. Okay, so this is the boundary of the cavern. Now here you can see there are two shear zones. One is shear zone A, another is shear zone B. So this shear zone A, it doesn't intersect the cavern, whereas this shear zone B, which is about 1 to 2 meter in thickness, it intersects the this cavern, and it is also aligned in obliquely inclined to the horizontal plane. So these are the materials which are there. Now I have tried to simulate the actual geometry. So this is my longitudinal section of the finite element mass, in which you can see that this is the cavern, and this is representing the shear zone, and this is representing the dolerite dike on this side. Now, this is the cross-sectional elevation of that. So you can see although the elements which I have used, these are not the finer element, but since I had to consider the entire mass, so I have used these elements. Now, this is the three-dimensional view of the entire underground cavern. You can see that this particular shear zone is going like this and intersecting, and it's intersecting with the intersections with the cavern is this. Now, normally we say that what is the use of engineering graphics? Why do we teach engineering graphics? And why do we teach this stereographic projection? So I can say here that without the knowledge of engineering graphics and the stereographic projection, I would not have been able to create this particular three-dimensional geometry. Now, after the analysis, I have taken into account the anisotropic rock mass with shear zone. Although I have analyzed for the isotropic without shear zone, with shear zone, anisotropic with shear zone, but since finally the anisotropic rock mass with shear zone is the actual condition, so these are the displacements which are determined, and displacements are exaggerate on the exaggerated scale. So this is the shape of the cavern after the. So please note that this is on the exaggerated scale. These are not the actual. And this shear zone is again, it is not to the scale, but it is intersecting the crown axis. So what I have done, I have determined the displacement all along the boundary of this particular cavern using this particular procedure, and those boundary displacements I have considered as the boundary condition for the shotcrete lining. So these are the stresses. This is the stress pattern. So I have tried to represent the sigma y and sigma z in the vertical direction and sigma y in the horizontal direction. So this is the variation. You can see that there is lot of concentration of stresses in a direction tangential to the excavated boundary. Now, if I plot it along the longitudinal axis of the cavern at the top of the cavern at the crown, then you can see that if I consider only the isotropic case or isotropic case with shear zone and anisotropic case with the shear zone. So from this slide, we can see that the anisotropic rock mass with shear zone is representing the actual stresses. Now you can see that the stress concentration factor has increased from, if I consider only isotropic case, from 2 plus to an isotropic case in which isotropic case only when shear zone is considered, so around 4, and then it has gone up to around 9.5. So there, the fact is that there will be lot of stress concentration near the shear zone boundary. Then I have analyzed the shotcrete and tried to find out the support pressure. Now, the shotcrete lining has been modeled by method of substructuring. The shotcrete has been modeled using a single layer of 20-noded isoparametric brick element. The portion of shotcrete modeled includes that in the side wall, the crown, and on the southern face. The southern face has been included due to the presence of the shear zone B because it is intersecting. A layer of joint element has been added above the layer of the brick element to simulate the influence of the surrounding rock mass. Now, the displacement derived from the analysis of cavern have been applied to the outer surface of the joint element other than in contact with the shotcrete to obtain the displacement, support pressure, and the stress in the shotcrete. The internal surface of the powerhouse has been developed. So this is the developed portion of this. So here you have got the this complete development of, so this is at the southern side. So this is the shear zone here. And this is the shotcrete lining. Again, it is not to the scale. So the boundary conditions have been imposed by assigning the displacements at the corresponding nodes lying on the outer surface of the joint element. The elements in shotcrete layer lying at side wall, floor junction have also been subjected to the prescribed displacements equal to the displacements obtained from the analysis of the cavern at the same point. And these are the material properties for the shotcrete. So these material properties, I have taken the material properties for the concrete. Now, each joint element has a spring in the direction normal to the surface of the shotcrete. So the stiffness matrix has been determined. That is the pressure divided by the displacement. So that pressure is due to the normal in situ stress divided by the displacement due to the release of the in situ stress. So since the in situ, the top surface means the overburden is varying all along the boundary of all along the cavern. So I have tried to find out the normal in situ stresses, varying normal in situ stresses at different locations. So I had to divide this into 13 regions. So here the different values of the normal stiffnesses and shear stiffnesses are given. Now with that, I have then analyzed it. Now then I have tried to find out the displacement of the cavern. Now you can see here that these are the displacement without the cavern and these are the displacement with shotcrete, and just near the shear zone there is a kink. So there will be relative displacement more. But if we apply the shotcrete lining, then with shotcrete you don't see this particular kink. Now these are the displacements of the downstream wall. This is near the shear zone or just at the shear zone contact. Now these are the displacements of the upstream wall, and again these are the displacements. So near the shear zone you can see, and you can see the effect of the shotcrete. Now the effect of shotcrete is not predominant. It means this shotcrete is simply acting as a layer. The application of shotcrete layer has reduced the displacement only marginally. So the effect is more pronounced at the crown, whereas in the side wall the reduction is small. It can be seen that the kink observed in the displacement at the shear zone has disappeared due to the shotcrete lining. However, very high shear stresses are likely to develop in the shotcrete lining under such conditions, and this has also been confirmed by the appearance of the cracks in the shotcrete lining in the vicinity of the shear zone, a study done by Devatia and Trivedi. On comparing the permissible stresses with the induced stresses in the shotcrete, it has been inferred that the induced hoop stress and shear stresses are much higher in the vicinity of the shear zone than the permissible stress in the shotcrete lining, which can cause cracking of the shotcrete in the shear zone. The lining therefore requires additional measures from the safety considerations. Then the normal stresses on the joint element will directly provide the support pressure exerted by the rock mass on the shotcrete lining. So the variation of the normal contact stress, that the support pressure at the crown along the cavern axis, has been presented in this particular figure. You can see these are the support pressures which are required. Naturally, the support pressure in the area very near to the shear zone will be high, and then away from the shear zone. So the support pressures are high in the vicinity of shear zone of the order of 75 to 115 kilopascal. You can see here 75 to 115 kilopascal and 50 to 65 kilopascal away from the shear zone. The higher support pressure in the vicinity of shear zone may be due to the presence of weak rock mass and are corroborated by the corresponding high displacements. The roof support pressures thus obtained have been compared with Barton et al. 1974, Barton 1989 approaches, and Bhasin et al. In 1995 and Grimstead and Barton have advocated the use of mean value of Q around the weak shear zone. On the similar lines, I have suggested that the mean value of the joint roughness coefficient JRM should also be used in estimating the support pressure. So what I have tried to do, I have tried to find out, this is the data based on the study given by Ramaswamy et al. They have determined this Q parameter, RQD, JN, JR, JA, JW. So near the shear zone, I have said that we should go for determining this uh, the effect of the shear zone, etc. So here, this is jointed basalt, this is jointed dolerite, then in shear zone, then mean value of the shear zone. So the roof support pressure and the wall support pressure as per the Barton criteria is determined from these two equations. So in this, they have the Grimstad has suggested that we should go for this Q mean. So they have given this relationship. So I have also suggested that we should go for the effect of the shear zone material on the value of JR. So and then I have determined the roof support pressure from my this study, present study FEM, then NGI Barton's 1974 system, and then the typical range which are suggested by Barton in 1989 paper. So you can see that the support pressures are in agreement what have been suggested by the Barton. So I can say that this is an alternate approach by which we can also determine the support pressure. So finally, the conclusions are that the shotcrete behaves essentially like a membrane. The stresses in the shotcrete are higher than the permissible stresses, especially near the shear zone. The influence of shotcrete is negligible as far as the displacement behavior of the cavern is concerned because of its low stiffness. The influence of shotcrete is negligible as far as the displacement behavior of the cavern is concerned because of its very low stiffness. The long-term support pressure computed in the present study are in good agreement with those obtained using NGI criterion of Barton et al., even near the shear zone. However, wall support pressures away from the shear zone are negligible due to the lower stiffness of the shotcrete in the horizontal direction. Failure of support system in and around shear zone is indicated both in the present study and the recommendations of Jetwa et al. Of CSIR's Simford Dhanwad based on the empirical classifications. Lecture, thank you so much for patient hearing.
Thank you, sir. Thank you, Professor Samadia, for your excellent lecture. Let us have one or two questions. In the chat box, I am not seeing any questions. Sir, Professor Samadia, sir, is there any questions? Are there no questions? I think. So if anybody is having any clarifications, one or two clarifications, questions.
Sorry, good morning, Professor. Thank you very much for the nice presentation. I'd like to ask one question. My name is Dr. Anil Charyan. Just want to know, have you considered the shrinkage and the hydrodynamic pressure for the model like the shrinkage properties? Because the short concrete, I think you have the high shrinkage and the hydrostatic pressure issues, correct?
Okay, your voice is not clear. Can you put your question in
the shrinkage? Yeah, I can put that one. Hydrostatic pressure, that is the main thing I was asking. Whether have you considered hydrostatic pressure issues in the design?
I think you type in the chat box, sir.
It's okay, good. No problem. Okay. Thank you.
Anybody else? You can write. Okay, Dr. Anil Charyan, you can get it clarified. You can put it in the chat box and you can talk to him. Okay, thank you very much, sir.
Okay. Thank you.
For your.
I think I finished in time.
Yeah. Thank you very much. Now I request our co-chairman, Professor Thagraj, to summarize the lecture given by Professor Samadia.
Thank you, Professor Ramesh. It was very good lecture by Professor M.K. Samadhya sir, our president for 21 and 22. He very nicely brought out the analysis of shotcrete lining on the cavern. So that is especially on sir. Mute sir. Yeah, sorry. So nicely brought out the project of Sardar Sarovar underground power cavern. So he presented initially the finite element analysis, considering anisotropy and isotropy with shear zone, without shear zone, and elaborated the method of subtracting. And also he nicely brought out the displacements with the shotcrete, without shotcrete, and he clearly brought out that displacements are more pronounced at the ground. And similarly, he brought out the support pressures. They were also very high at the ground, nicely brought out. So this was a very good lecture on the cavern. So we got a very broad understanding. We considered the joints and informalities in all the rocks. It was very elaborate. Thank you very much, sir.
Thank you, Professor Tagraj.
So muted.
I thank both these speakers, Dr. Anil Joseph and Professor Samadhya, for their excellent theme lectures. Now, the paper presentation session starts. There are actually 8 papers. Out of 8 papers, I don't know, some in the chat box I could see 3-4 papers. And I request the co-chairman, if you have the list, Professor Tagraj, list of papers.
Sir,
yes,
I have all the papers.
I have the list, sir.
Oh,
yeah. Should I go about, sir?
Shall we call one by one, Professor Ramrao?
Yes, sir. You have to identify the 2 best papers also, sir.
Yeah, that will note down.
Okay.
All the 8 are presenting?
No, sir. We have received information of only 1 paper. So, the theme 7001 only, we have received reply to the chart.
Okay.
So, anyone others they are going to present? So, kindly give your information, the theme number and paper number in the chat box.
Okay. Now, let us start with the first paper.
Yes, sir.
Our co-chair will call the first paper by Arun Kumar K. No? So you can read the title and then invite him. Professor Tagraj.
Yes, sir. Yes, sir. Yes. So how much time are we giving, sir? Since we do not have
6 minutes.
Okay. So whether other papers are also not there, it's 6 minutes.
If the other papers are not there, he can take 2 more minutes. No problem.
No problem. So we are on the forensic geotechnical engineering and tunneling and deep excavation theme. That is both combining theme 7 and theme 13. So we have the first paper, engineering performance of foundation of Tanjavur Bradeshwar temple by Professor Premalata and Arun Kumar. I request the presenter to start and strictly stay with 6 minutes time.
Are you visible my presentation, sir?
Yes, please go ahead.
Okay. Good morning to all. My title is the engineering performance of the foundation of Tanjavur Bradeshwara temple under my project guide Dr. K. Premalata, Professor CEG Anna University. And the introduction, the monument is a type of usually 3D striped structures. It is the remembrance of historic times and the culturals and then the social activities and the remembrance of their person and etc. These are the classified into the 3 major types, the cultural heritage site, natural heritage site and mixed heritage site. Cultural heritage sites are the historic building, natural the elements of the biodiversity, mixed the both natural and the cultural heritage site. In India, have the 23 heritage structures and then 5 natural sites are there. In majorly ancient monuments and divided into the 2 parts. One is surface monuments and subsurface monuments. Surface monuments means the in temple. Subsurface monuments means caves. And then my project is involved into the performance of the Tanjavur Pragadishwara temple, because this is the 1000-year world temple and this foundation is very different from the other types of the foundation. Because this type of foundation resembles to the Tanjavur marble head tall. In Tamil, Tanjavur Kalayati Bommai. In to shake this tall, come after the vibrations, the stopping, they come to into the original position. So this tall resembles the this temple foundation. So my objective of the study is to present study to understand the engineering performance of Tanjavur Pradeswara Temple Karpagara Tower foundation for static load conditions. And then these are the literature's review I collected for this study. And the first one is the analysis of historical structures. Then Iwaski et al. The study about the ethnicity of soils and foundation heritage structure beyond temple in Angkor, Cambodia. In this temple, the original ground was excavated into the 2 to 3 meter. That soil was removed, filled with another type of the strength soil. Then foundations are made. And then et al. Studied about the visual modeling Chinese temple construction for student education. This temple was the originally the ground soil is removed, the densified with sand condition without in rigid boundary, the temple was constructed. Next one, the Prisloaki and Silinska studied about the behavior of the foundation of historical buildings of 16th century detail analysis. And Taka et al. Studied the sandbox technique that was used to build the foundation for two major temples in Telangana, Ramappa temple and Thousand Pillar temple. And the Vethivavijan et al. Studied about the model verification of soil historic measurements. And Professor Sargunan studied about the big temple in Tanjavur. Next one, the testing behavior of granite. In West Corners et al. Studied about the compressive behavior of the granite. And then this is my methodology. The first, we study on the temple history and constructions and the collection of subsoil profile details, temple details with the dimensions, study and seismological parameters, and then finally all details are collected to run the numerical analysis for static load conditions with varying boundary parameters. Without the boundary condition, rigid to flexible boundary condition to vary, and get the results and analysis, finally conclusions. This is the plan view of the Tanjavur Prakadishwara temple in Tanjavur, Tamil Nadu. Next one is the special features of the temple. In Prakadishwara temple is the 1,000-year world temple built by the Rajaraja Solan and the architect with the help the Kunjuramallan Rajaraja Perutachan. First tallest and only granite temple in the Asia in 66 meters. The based on the Indira Gandhi National Association in Science and Arts, by measuring the geolite around the temple height was measured 59.68 meter with the angle of mean 0 degree in constructed in span of 7 years. Shadow does not fall on the ground in afternoon. Then another one is the 80 tons carved single rock in the top of the temple, and the inside the temple 9 feet tall Sivalinga, and then he's celebrating the 1,000-year celebrations, and the shadow tower interlocking technology we used in temple constructions, and 12 feet high in Nanda in front of temple, and the celebrating 1,000 years commemorative coin will be released. These are the photo taken in the inside the temples. Next one, I will take some properties and details by the Sargunan studied about the big temple Tanjavur. The building material is granite and the compressive strength. We use the laterite rock strength and ground strata conditions. The temple type, foundation type, load intensity are taken into the book of Sargunans. The archaeologists of Chennai Circle conduct a load test on small sections of the rock in the side of the temple. They take the test plot 1.2 meter to 1.2 meter. We visualize the stone blocks layer at 0.6 meter, 0.6 meter, 0.6 meter in foundation. Based on its study, the tower was designed for the zero settlement. And this is by Sargunam, the big temple's communication, the foundation raft in square meter 108 modulus, that is the of the 36 meter with zero settlement foundation. During the 1,000-year celebration, the archaeology circle, Chennai Circle, drilled a borehole in the inside the temple, around the temple by the 15 meter, drilled a borehole. Then at that time, we got only in the sand material only. That sand was different from the surroundings natural soil. Because of that sand, only the surrounding natural soil is only red clay soil only. But then dense sand was climbed from the borehole too. So based on the result, the complete based on discussion with the archaeologist who worked in Chennai Circle, the foundation was construction with cushion type material. So this type of material resisting earthquake loading conditions also, because this temple resisted in the many 6 earthquake in for past years. This is the subsoil profile DTS we collected from the State Ground Surface Water Resource Data Center, Taramani, Chennai. So that below the sand was filled with the Kataru sand. The Kataru sand is mainly different from the other type of sand in dense conditions filled within the rigid boundary. Next, numerical analysis. In Plex is 3D software used for the numerical study with varying parameter of the Young's modulus of the boundary material without the boundary, and the next one the with boundary varying with height of the boundary, thickness of the boundary. The cross section view of the foundation showing this is the thickness of the boundary with filled within sand in dense conditions. And the next one is the load applications with 36-meter raft foundation. The uniform surface load is 500 kilonewton per meter square. It's 2-meter square raft and then height of the boundary. The validations are done from the Plaxis 2D settlement contour Mutali Desai and Askas Axai Mutali Desai 2017. We done in Plaxis 3D, take the settlement contour, compare the results, so the analysis are valid. And this is the material property I used for the analysis: laterites, sandstone, granite, sand mixes. These material properties are taken from the corresponding IS codes and the varying parameters. We take the height of the boundary, thickness of the boundary. The raft thickness, Young's modulus of the rock mass. This is the results and discussions. We conduct in static load analysis. We plot the graph for height of the boundary with respect to the displacement. We change in the boundary thickness value 2 meter, 3 meter, 4 meter. For the displacement value 2 meter raft, 2 meter thickness boundary is more than the 2 meter of 3 meter thickness of the, because the boundary thickness increases, displacement distributed along the sides of the confinement. Next one, the vertical stress versus the height of the boundary. The most of the stress due to applied load taken by the boundary of the sandbox. The maximum stress values applied all the coordinates are located in this boundary locations only. This is the stress distribution diagram shown in here. And next one is that varying the Young's modulus to this type of constructed by granite stone only. We don't know the correct the Young's modulus. To varying the Young's modulus 40 to 70 kilopascal, the Young's modulus value increases, settlement value decreases, but the Young's modulus value 60 to 70 kilopascal, they are almost the same settlement values. Conclusion: for numerical analysis, static load analysis, we concluded from Tanjavur Pradeeshwara temple designed for zero settlement criteria. So this zero till criteria based, the foundation dimensions are arrived: 36 meter square raft, thickness of the footing is 2 meter with 3 meter boundary thickness and 8 meter height of the boundary gives the approximately zero settlement and low stress values compared than the other dimensions. Because of the confinement, the most of the stress due to the self-weight of the temple taken by the boundary of the sandbox. Next, the future studies. The earthquake load analysis. Because of this point of foundation, this is the earthquake loading also. In Tanjavur, the low earthquake zone is under the earthquake zone 2. But this type of temple, how will the response in earthquake loading conditions also analyze to varying the magnitude and the accelerations to in further future study. Thank you.
Thank you. I think question and answer session will put it on the end. Arvind is there. You can invite Arvind PS. Mr. Tagraj. Mr. Tagraj? Forensic analysis of retaining wall failure by Arvind PS. And Neerad Mohan. Arvind PS? Hello? Arvind?
Yes, sir. Is Arvind there?
Sir, yes, sir.
Please go ahead. You take 6 minutes.
Yes, sir.
Should I go to the next paper, sir? Otherwise?
Arvind is not there?
I'm ready, sir. I'm ready.
Arvind,
Yeah, please.
I'm ready, sir.
Go ahead. Time is up. Please start immediately.
please present.
Please, sir. Please present.
Yes, sir. Yes. Sir,
Time
is it
up.
visible? Is it visible?
Yeah.
Yes, sir.
You please take strictly 6 minutes. It is 12:49.
Yes, sir. Good afternoon, everyone. I'm going to take a presentation on forensic analysis of retaining wall failure. A gravity retaining wall collapsed on 11 July 2019. It is present in Chalakudi in Kerala state. It's owned by the Indian Railways. It's a 15-meter long wall. Width is 1.5 meter and height is 3 meter. It is located along the Chalakudi river basin nearby the railway track. The region has a history of slow failure and landslides. So as you can see, this is the retaining wall and near the bridge. To perform the forensic geotechnical analysis to determine the cause of failure of retaining wall by collection of field data, characterization of distress, development of failure hypothesis, diagnostic test, and back analysis. Scope. Objectives: to determine how the train-induced vibration acts as a trigger mechanism leading to liquefaction and settlement of the surrounding soil, to determine various static and dynamic forces acting on the retaining wall, and to compare the conventional back analysis and numerical back analysis methods with the actual site deformations. This is the wall which has collapsed and fallen into the river. Methodology. Initially, literature review was done, followed by development of failure hypothesis. Field recognition survey was conducted, distress pattern classification, followed by standard penetration test to determine the soil profile. Samples were collected, various engineering and preliminary tests were conducted to determine the type of soil, and then field instrumentation and vibration analysis was performed using accelerometers, and then followed by back analysis. Failure hypothesis. Various failure hypotheses were developed. This is stresses induced due to the train-induced ground vibrations, unfavorable soil condition, susceptibility of soil to undergo liquefaction, increase in active lateral pressure, river-induced hydrodynamic and hydrostatic load, and then distress pattern classification was characterization was performed. As you can see, the wall shown in yellow color is the actual existing wall, and the wall shown in blue color is the deformed wall. This is the first image shows the sectional view, and the other image shows the top view. The levels at different points were determined. The distance from the abutment was taken as a reference, and the settlement was measured, and lateral displacement was measured with respect to the distance from the abutment. This is the lateral displacement vertical settlement of the wall, showing the distress pattern characterization, which shows that as we move away from the bridge abutment, the deformation as well as the settlement is less. Various cracks. This is the standard penetration test that was performed to determine the soil profile. As we can see, the end value seems to be quite loose, varying to medium dense and then dense, then to very dense. The core recovery was obtained, which shows core of a good recovery. Various tests were conducted as per preliminary engineering analysis. Actual compression test was performed on the trial pit samples to determine the shear characteristics. Constant head permeability test was determined to determine the coefficient of permeability of the backfill soil and the foundation soil. Index properties and the engineering properties were determined. This is the graph showing the triaxial test on the backfill soil, which is predominantly clay sand, and the foundation soil, which is poorly graded sand. The sample. This is the result of the constant head permeability test, which shows that the soil which was used as backfill is semi-pervious, which has a poor drainage property. Similarly, the other soils which are present in the foundation layer, that is a poorly graded sand, is having a pervious nature of a drainage characteristic. Now we come to the determination of dynamic analysis, that is determination of the ground motion. It was determined by using ADLX 335 triaxial accelerometer. It is used to measure the ground acceleration in X, Y, and Z direction. Basically, by using this ground motion parameters, the soil dominant frequency or the eigenfrequency or the natural frequency of the soil was determined. As from various journals, it is known that when the soil is subjected to dominant frequency, it undergoes liquefaction. So basically, our aim was to determine the natural frequency or the dominant frequency of that soil layer. As you can see, this is the triaxial accelerometer, this is the railway track, and it was placed in 9 different locations. This is the retaining wall. The three locations were located very close to the retaining wall, and other three were located far away from the retaining wall. And the ground acceleration versus time graph was obtained. The fast Fourier transform was performed on this acceleration time graph, followed by application of various filters to remove noise to obtain the dominant frequency representation. That is we converted from time domain to frequency domain. From that, we obtained the various displacement, acceleration, and peak particle velocity. As we can see, this is the vibration analysis result. The vibration, which is peak ground acceleration measured in G units, is maximum in the location A1, which is located very close to the railway track, and it is least in the region which is located far away from the railway track. From the results, we obtain the peak particle velocity as well as the dominant frequency. As we can see, when we move far away from the railway track, the ground acceleration reduces, induced by the train vibrations, it reduces. Similarly,
time is up. Please wind up.
Yes, sir. So, the analysis of liquefaction was also performed by using cyclic stress method from cyclic stress ratio and cyclic resistance ratio. It was determined that the soil layer which is present at 10 to 12 meters is prone to liquefaction. Similarly, the various lateral active earth thrust on the wall was determined by various Coulomb's methods, Monod-Hamel method, and Richard Helms method to determine the various coefficient of active earth pressure and lateral thrust on the wall. The stability check was performed: stability against overturning, stability against sliding, and bearing capacity failure. Two criteria were determined. The first criteria, in which the water level or the river water level was assumed to be in between the wall, and one in which it is not, water level is not present. Thus determined that the wall underwent bearing capacity failure. The settlements were determined. Numeric analysis was performed by using Plaxis 3D, and the deformations were obtained. As we can see, the procedures followed were: number one, seismic displacement analysis as settlement calculation. The lateral displacement was obtained. This was 100, which was 100 mm. It was determined by Nandakumaran et al. Method for solution for pure translation. The vertical settlement was obtained similarly by Steinbrenner's settlement equations. Numeric analysis showed similar results. The distance measurement showed the similar results. The causes of failure was found out to be liquefaction, which is induced by the train as a result of the soil was already prone to liquefaction, and when the vibrations are induced by the train caused a further liquefaction in the foundation soil. Similarly, unscientific design leading to bearing capacity failure, poor impervious backfill soil, lack of drainage, and increase in net lateral thrust on the wall due to dynamic earth pressure and hydrodynamic pore water pressure acting on the wall. Thank you.
Thank you. Next paper is re-evaluation of failure of silo tower foundations by Shivabhushan, Asif Ali Mohammad, and Professor Madhav. So, who is presenting?
Hello.
Professor, yeah, you are there. Asif, please go ahead.
Yes, sir.
You have just 6 minutes.
Yeah, okay, sir. Good afternoon, all. Myself, Muhammad Asif, PG student of VNR College, Hyderabad. My topic is re-evaluation of failure of Silo Tower Foundation. My co-authors are Shivabhushan sir and Emeritus Professor M.R. Madhav sir. This is the outline of my presentation. Coming to the introduction, silos, in case of when silos are constructed on weak compressible clays, it gets overturned, tilted, fewer get collapsed due to bearing capacity failures. So in 1951, Skempton has given a bearing capacity equation for homogeneous clays. QU is equal to CNC plus P, where cohesion, overburden, P is overburden pressure, NC is the bearing capacity factor. After that, in 1973, Davis and Booker has given an equation for non-homogeneous clays, where the shear strength will increases with depth in the soil. We can see the rho is the rate of increase of shear strength here. He has given the shear strength profiles, and this is the equation which he has given: QU F by CU naught is equal to F of NC plus rho D by 4 CU naught. F is the correction factor of the foundation. So this is the correction factor value which we can take from the with Rodi by CO naught parameter. So I am coming with the desiccation topic. The desiccation is in clay soils, the soil which is exposed to atmosphere due to seasonal changes. It get when reheated, it gets swells, and due to the uh, drought conditions, it gets sinks. We can see the image over here, the cracks over the soil. This causes the significant change in the density in the topmost layer of the clay. This phenomena we will call as desiccation. So due to this desiccation, there will be a damage to the building. So we can see here, these are the some case studies which the Bozazuk has taken from the silo failures of in Canada. You can see as we can the this is the borehole data, desiccated reddish soil we can see, and after that soft gray silty clay with some black mottling. In this one, from uh, in the top surface where the desiccation is there, we can see the decrease in shear strength. After that, as Davis has proclaimed, that we can see that increase in shear strength. But Bozozuk had said this silo has failed due to the non-uniform loading and overlapping of the pressure berths of side-by-side silos. And one more Richmond silo, we can see the desiccation phenomena here, where the brown desiccated clay silty soil is there. We can see the decrease in shear strength, and from that, by the layer to layer, we can see the increment of shear strength here in depth. So I have taken the sketch diagram of the shear strength with non-homogeneous soils having desiccation over the surface. In I have taken the footing into the desiccation soil. From the base of the footing, we can see the decrease in shear strength and increase in shear strength after completing the desiccating zone. Z0 is the depth of desiccating zone. Df is the depth of the footing. This CUB is the shear strength at the base of the footing. CU0 is the shear strength at the interface of the two layers. So this is the free body diagram of soil mass which is below the footing. You can see QEF, which we are going to derive the equation for it. QEC is the equation of non-homogeneous clay soils, which already Davis has given. We will incorporate this equation into our equation. And there is adhesion factor due to the soil mass, adjacent soil mass and the footing. So I have taken the Mayer-Hoff concept of two-layer soils here, which he has given in 1978. We can see the normally consolidated clay has bearing capacity which is lower than the desiccated desiccation bearing capacity coming from the desiccation. Q1 is the desiccation bearing capacity. Q2 is the normally consolidated clay bearing capacity, which is non-homogeneous. So for that case, we can find out that Ca value from this equation which is given by the Mayer-Hoff. Taking this Q2 by Q1 ratio, we can find out the adhesion value. So this is my equation which I have derived for normalized bearing capacity of the soil desiccated with non-homogeneous clays. You can see correction factor, adhesion value, and Z0 by D is the thickness of the desiccation with respect to the depth, and this is the df by Z0 is the depth of the footing in the desiccating zone. Using these two parameters, I have derived some plot. I have given some plots. Normalized bearing capacity with respect to the Rho by CO0. We can see as the depth of the footing is decreasing in the desiccating layer, we can see the increment of bearing capacity. We can say that because as we are going deep into the desiccating layer, which we have seen in the previous images, the shear strength will decreases. So there will be a decrement of bearing capacity. So we have to provide the footing at the surface of the desiccating layer. If we provide, so I am mainly talking about the shallow foundations. If we are considering for the deep foundation,
you have 1 minute to conclude.
Okay, sir. So this is after that. This is a thickness. This is a Z0 by D thickness with respect to thickness. As the desiccating length increases, we can see the increase of bearing capacity. This is the equation I have taken from the Skempton and then shear strength equation, and I have derived I have plotted the graph. And this is the values which I have taken from the Van Cleef silo, Richmond silo. These are the shear strength parameters which this is the bearing capacity comparison. We can see Bozozuk has given the bearing capacity of 205 kilopascal, but after taking the Bozozuk's and Mayer-Hoff's approach of clay soils, I got 151.3 kilopascal of bearing capacity. There is, so I am going to conclude that I have taken failure of silo reported by Bozozuk in the geotechnical point of view, and new theory of Mayer-of approach I have used in this one, and I can say that bearing capacity from the given by the Bozozuk are less. What I got is less than the 20 to 26%. As it is failed, we can say that even he said the it has the ability of 250 kilopascal, but even it but due to the desiccation phenomena, the bearing capacity of the Richmond silo is only up to the 201 kilopascal only. That's why this has failed. These are my references. Thank you.
Yeah, thank you, Asif. I think we can take the questions at the end if time permits.
Yeah.
Now, next paper is rock mass index to estimate the shear strength parameters of the rock mass. A case study from Lesser Himalaya, Jammu and Kashmir by Pratap. Pratap, please stick to 5 minutes. Please share your screen. Pratap, are you there, Pratap? I saw him. Okay, if you are not there, we'll move to the next presentation. Pratap, are you there? Maybe you lost connection.
Okay, go to next non-linear finite element stability.
Yes, next paper is non-linear finite element stability analysis of tunnel in sandstone against blast load by Zahid, Rehan, and Siddiq and Alam.
He is also not there.
Okay, we'll go move on to the next paper. Modeling of diaphragm wall for deep excavation in sandy soil by Mandeep Singh and Balveshwar Singh. Any of the authors are present?
Chat box is not there. He is not mentioned.
Okay.
Go to next paper. 4 is also not there.
Next paper, whether Surendra Singh Pawar sir is there?
He is there. He is there. Surendra Pawar.
Yeah. Next paper is the light at the end of the tunnel. The Silmanabad tunnel by Professor Surendra Singh Pawar. Over to you, sir. Can you please share your screen and present?
Yes. Good afternoon. The paper is the light at the other end with respect to Silmanabad tunnel. It is a Herculean task to build a tunnel in mountainous earth, loose soil, especially when there is no adequate cover compartment. Yet in Madhya Pradesh, the project is underway by Narmada Valley Development Authority. Before talking about the topic, I want to share a mythological story from Narmada Purana. According to that, the two rivers originated from the ranges of Bengal, Narmada and Sonbhadra, represented an physical went away in opposite direction, and made to be two bedrock by constructing 12 kilometer long and 10 meter diameter tunnel is being constructed between 104 to 116 kilometer of Vargi project.
Sir, please excuse me.
The region is densely populated.
Yeah, please go ahead, sir. Please go ahead. We can see your screen now.
The region is populated and by NSM as well as Mumbai railway line. The tunnel is a part of larger Vargi diversion project. Once completed, up to 194 kilometers will show irrigation over 2 lakh hectare land and give water to area of Patni, Riva, Panna and Devalpur district. It is point to notice that in project plan, that part of canal was proposed as cut. Project means Silmanabad irrigation tunnel, client Narmada Valley Development Department, Madhya Pradesh. Turnkey project awarded to joint venture company Messrs Patel Engineering, SCW and Coastal Project. Design weighted by CWC Delhi. Agreement amount 799 crore. Stipulated time for completion 40 months from 26 March 2008. That is date of starting of work. Now, geological alignment of tunnel. In this alignment, we can see length of tunnel is 12 kilometer, minimum cover 9.5 meter, and maximum cover 33 meter over crown of tunnel. While as per geotechnical report, in lower diagram, geology changes frequently meter to meter. It consists soil, silt, limestone, dolomite, slate, and rust marble. Now TBM section. As per technical report, 68% soil and 32% competent rock. So Robin CPV hybrid machines was used. This is the on-site assembly, TBM assembled at site rather than manufactured facility. Electrical and subsystem were tested before shipped to the job site. Tunneling start from downstream end until 2011. It means about 3 years consumed to decide the type of TBM manufacturing company supply and setting of the tunneling. Now project launch. After launch of TBM, multitude commercial, technical and geotechnical problem faced. Commercial is not in the scope of the full length paper. 2 years breakdown to technical and geotechnical problem, mainly cutter had ruined and including traversing downside to rock. On September 2050, means after 4 years of digging and 7 years of demand, the tunnel was 1600 meters, that is 30 meters per month average. While as the roadmap of tunnel submitted by agency to agreement, it was 330 meters per month. Then I recommended deploying another TBM at upstream site, construction of 2 or 3 intermediate softs, and possibilities of open to expedite the tunnel activity. Sooner, the agency deployed another team in 16 and involved Robbins into technical supervision in September 2017. Now, this is the high-level timeline of work. This is the diary of tunnel showing physical activities during tunneling. Next. After 12 years, physical progress is 42%. And
please conclude, sir.
Yes, sir. Financial progress was 47%. So, client has taken ultimate measure to convert tunnel into open cut in 6 kilometer virgin patches. Now, conclusion, still hope at the end of dark tunnel, as I think the agency had not performed the due diligence before batting with Robbins TBM. Consequently, they had to borrow experienced and skilled staff of Robbins at downstream, as well as to take drastic measure to deploy another HK TBM at upstream. The client has also taken some late decisions, hoping that the construction in new framework could be completed within time, that is up to June 2024, and allocated quota of Narmada water according to Narmada tunnel could be utilized fully, and finally transfer water from Narmada basin to Ganga basin through Son command to serve Dartpon area at the other end of Dart tunnel. That would also be a poetic closer to the story Narmada and Sonvad, two strange lovers would finally meet. Thank you very much.
Thank you.
Thank you, sir. The next presentation is by Jishnu on the topic static and dynamic assessment of tunnel rock supports in weak rock. I request Jishnu to present. The co-authors are Vineet, Nitiki Lekha, and Professor Shrideep. Jishnu, are you here? You said you
yes,
are there.
Yes, sir.
Yeah,
yes,
please share your screen. Just take 5 minutes.
Yes, sir.
Because we are
Is my presentation visible?
Yeah, it's visible. Put it in the full screen mode.
Yes, sir. Good afternoon to everyone. The topic of my presentation is static and dynamic assessment of tunnel rock supports in weak rock. Is it visible, sir?
Yes, yes. Go to the PPT. It's visible.
You can directly go to the PPT and you can go to presentation mode. It is visible. Go to presentation mode.
Okay, yeah, it's visible.
Myself, an MTech student in Geotechnical Engineering at IIT Guwahati. The
Sorry
abstract of
for
my
interrupting. Please go to presentation mode.
Full screen mode. Yes.
Yeah.
Yes, you're good to
So
go.
the abstract of my presentation is that as we did design any tunnel, so it involves a lot of high risk, and an improper analysis can lead to several financial loss. So a conventional, although the empirical methods are available, such as the Q system or any other or the RMR, the we should always combine the empirical methods with the numerical analysis, so that a better interpretation of how the stress distribution, the plastic deformation, or the yielded elements is visible for, and so that we can come up to an optimal support system. In the present case, a tunnel from Khadka and others 2017, which is at Nepal, has been taken into consideration, and it has been designed for both static and dynamic loading using phase 2 of rock science. And the dynamic analysis has been performed by both pseudostatic and time response method. And finally, it was concluded that shotcrete alone was sufficient in order to cater both the static and dynamic loading. So generally for the support system, we have two types of support system. One is the primary support system and secondary. For in primary support system, we have the rock bolts, steel sets, and shotcrete. And for the secondary liners, they are generally provided for corrosion protection, water tightness, aesthetics. And then because it's a weak rock, for a weak rock, its UCS is generally less than 50 MPa, or it is less than 1/3 of the in situ stresses. And the weak rocks are subjected to high squeezing and weathering. First, we have used the Barton and others empirical approach, where we have obtained the Q value, which is the average Q value of 0.785, and the data geotechnical investigation report given in Khadka and others 2017 has been used in this analysis. Now, because a detailed geotechnical study was not carried out along the entire tunnel length, so average Q value was obtained. As per the Q value, and referring to the Q chart given by Barton and others 1974, it was seen that the support categories fall under the fourth region, which gives a spacing of bolts of around 1.5 meters, length of bolts 3 meters, diameter of bolts 1.9 centimeter, and thickness of shotcrete 10 centimeters. For the numerical approach, we have used the phase 2 version 9 2D elastoplastic finite element program. The tunnel dimensions are again taken from Khadka and others 2017. Because there were joints, and in order to incorporate the joints, now phase 2 cannot carry out this discrete element modeling, so interface elements were used, and for the interface elements, interface properties were then used for the joints. And then for the strain softening case, we have used the generalized Hook-Brown failure criteria. So the mesh was discretized using 6 noded triangular elements of 1413 number, and it consisted 2991 nodes. So the inverted D-shaped tunnel was of 3.5 by 3.5 meter, and it was located at 35 meters depth. The set of joints were considered at 60-degree inclination at 1 meter spacing. And then for the numerical approach, again, the data, whatever was given in the Khadka and others 2017 has been tabulated here. From the static analysis, it can be found that the induced stresses, that is the sigma 1 and sigma 3, are less at the inverts and compared to other locations before and after the support installation. But the total displacement is higher at the invert. Now, negative minor principal stress, that is the tensile stresses for the unsupported condition, has been checked by the installation of supports. And then significant decrease in total displacement with installation of supports can be observed. But no significant change in displacement can be observed for support system with shotcrete alone or combined shotcrete and rock bolt. For the pseudostatic condition, we have used KH is equal to 0.3 and KV equal to 0.2, which is within the typically exploited values. And the KV was considered to be vertically downwards because the seismic coefficients, when applied downward, then it applies additional body force on each of the meshes. Now, in these stresses on left side, that is B, is more as direction of KH is taken towards right. Decrease in displacement due to support installation can be observed, and shotcrete alone was sufficient to control these displacements. For the time response analysis, we have taken the Nepal earthquake of 2015, which has a magnitude of 7.8. Both undamped and damped analysis were done for the dynamic analysis. The viscous boundary condition at the base was an absorbent boundary, and the vertical boundaries do not reflect outgoing waves. First, the undamped analysis was conducted. The values of Rayleigh damping constants are adjusted to alpha m equal to 0.0043 and beta k equal to 0.45 to achieve a Rayleigh damping of 5%. Then the damped and dynamic analysis performed again. On the figure on the right, we can see the horizontal component of the Nepal earthquake 2015 and for the vertical component as well. Now, the results of the time response analysis was that displacement on the right side walls, that is C, is more because the loading was considered from the right. Then the negative stresses were corrected using the shotcrete installation. Very high displacement as elements of the mode have yielded because of strain accumulation due to dynamic loading, and then 100% yielding of plastic elements could be observed. Now, as per the conclusions, that highly conservative results in the time response analysis is due to the high ground displacement amplitude considered for this model. Now, comparing the displacements, shotcrete alone was able to outperform other support conditions in terms of stresses, displacements, and yielded elements. The analysis represents that the safety of the structure is not directly related to the amount of support provided. The behavior of the rock mass to any kind of support system is entirely dependent on its properties. Therefore, a proper combination of both empirical and numerical methods can provide us an estimate of the response of the rocks to the tunnel construction. But nevertheless, we need to validate with the observational field data now. These are my references. Thank you.
Thank you, Jishnu. So now we have the last paper at the Pratap. When we called, he was, I think he has some network issues. Rock mass index to estimate the shear strength parameters of rock mass. Case study from Lesser Himalaya, Jammu and Kashmir. Pratap, please.
Yes, sir.
Please share your screen and restrict to 5 minutes, please.
Okay, sir. Sir, can you see me?
Your presentation is not up. I can see you, but please share.
Sir, on the bottom, the right side bottom,
now.
you can find present now option.
Select entire screen.
You can see 3 dots on the extreme right side bottom. Next to that, you can see present now option. Click on it. Select entire screen.
Yes, sir.
Yeah. Then again, the entire screen, you click there on the pop-up and then say OK. Yes. Please go ahead. We can see your screen.
Okay, sir. Thank you, sir.
Go to put it in the full screen mode, slideshow mode. At the bottom, there will be slideshow mode, you see.
Here I am going to talk on utilization of RMI in estimation of shear strength of rock mass.
Please change to okay, fine.
The shear strength of rock mass are mainly cohesion and internal angle of internal friction. Generally, Hope-Brown criterion is used to determine shear strength of the parameters. Here I have used RMI for estimation of S and N, constant of HB failure criterion, and finally the shear strength parameters have been calculated. This is my present work area, that is Anji Khad in Riasi of the Jammu and Kashmir. This is my study area where the rock mainly consists of Proterozoic Sirvan limestone and Riasi thrust in very close proximity. This one is the Riasi thrust and here is my study area. Now first I have done the detailed geological mapping of this study area. This is the geological map. And you can see that there are a number of joint sets and some strike slip faults is also there. Then the geostructural survey through scanline method, and finally the characterization of the discontinuities. These are the scanline surveys from where we can see these are the faults These are some open joints and some shearing is also there. There are some of these canine surveys. Now we have input data, that is rock compressive strength, HB aims factor for intact rock mass, that is MI, joint characteristics such as joint roughness, joint toleration, and joint length, then block volume and effective normal stress. And I have this calculation from the qualities given here, such as joint condition factor, scale factor of compressive strength, HB failure constant S and M, shear strength parameters, instantaneous friction angle, shear stress, instantaneous cohesion. What type of results I gave from here, that my characterization of joints in the area, I demarcated 5 zones: moderately jointed zone, closely jointed zone, very closely jointed zone, open jointed zone, and shear or faulted zone. These are some of the photographs showing the dolomitic limestone in this condition. These are the bedding planes which is considered as a discontinuity. These are the shearing going throughout the rock mass. Different ratings by following Palmstrom table has been assigned to discontinuities of these 5 zones. Then we have estimated
Cannot hear you, Pratap. I think there is some problem. Pratap, can you hear us? Okay, so I think there was some connection problem. I think should we wait, sir, Chairman sir, or should we take up some questions?
Okay, no problem. You can ask questions, one by one.
Yeah.
If there is any question from the first paper onwards, we can.
Yeah. So to the first paper, to the Arun, can we? Anyone has any questions for Arun Kumar?
Chat box, there is no question at all.
Okay. Okay. What about this, for the second author on forensic analysis by Arvind? Any questions, please? Or you can just ask your question to any author. Okay. So I think looks
If
like
there are no questions, you can briefly summarize and wind up.
Okay. So assume that there are no questions. You can get in touch with the authors, and you have any clarification you can do. So we had a very good session this afternoon on the topic of forensic geotechnical engineering and tunneling and deep excavations. We had 2 theme lectures, one on forensic study of earth retaining system failure by Dr. Anil Joseph. It was very elaborate how it failed. And then we had one more theme lecture by Professor N.K. Samadia, President of IGS, on analysis of shotcrete lining and estimation of support pressures of Sarovar Sadar underground powerhouse K1. So mainly wherever there were failure, there were wherever we have failure modes, there only was the pressures and support pressures are more on the lining system, that he brought out clearly. Then we had 8 contributing papers, but some of the authors could not come and present. Only 6 authors presented. So the topics were wide range. So starting from on the heritage structures, they brought out nicely of Tanjavur Videshwar temple by Arun Kumar and Premalata. Then we had mainly on the forensic analysis of a retaining wall failure by Arvind. So it was very elaborate study they brought out, and again that Asif Ali Muhammad, he brought out on the failure of silos, and there were studies on the rock mass index. The final it was not complete because of the connection problem. And finally, we had some topic on assessment of tunnel rock supports. So mainly on the tunnels in the rock and as well as the foundation failure and the forensic analysis on these broad topics. The papers were very good. So I hope, I'm sure that all of you agree that we had a wonderful session of technical session. Thank you very much. I hand over the session to Mr. Ramesh, chairman of this.
Thank you, Professor Tyagraj, for your excellent co-chairing. You briefed the themes of the papers and representation very nicely. And I too agree with you. All the papers are good. The presentation was good. And there are 6 presentations. Out of 6, we are going to select 2 best papers and we are sending it to the IGC 2020. We are really happy that all the 6 papers are good, and we have to discuss and we had to finalize the 2 best papers. And I once again thank the theme speakers and all the authors of the papers who presented in this session. I thank the session coordinator, Professor Ramarao, and co-chairman, Professor Tyagraj, theme speakers, Dr. Anil Joseph and Professor Samadhya, and all the authors and all the delegates who are present and supported authors who presented the paper. Thank you very much. Now I am handing over the session to our session coordinator, Professor Ramarao.
Thank you, sir. So I am thankful to Chair Professor H.N. Ramesh and Co-Chair Professor Tyagaraj and theme speakers Dr. Anil Joseph and Professor Samadhya and others of the contributory papers, and also the participants for this session. It is a wonderful session. So thank you one and all. So I will declare the session is closed.
Thank you. Thank you.
Thank you, everyone. Have a good day.
Thank you, sir. Thank you one and all. So Mr. Vinil, we can close the session.
Yes, sir.
Tyagraj, we will discuss over phone.
Okay, sir. We'll discuss on phone. Yes.
What time? I have one more session at 2 o'clock.
You tell me, sir, at what time you are free. Then
in the evening sometime.
Yeah, please call me. Yeah, please call me. Please call me. Thank you, Professor Ramarao garu.
Thank you. Thank you very much.
Thank you, Professor Ramesh garu. Bye. I'm logging off, sir.
Yes.
ఇప్పుడు సార్ మన సైకిల్ ఇరవై ఉంటుంది నాకు అంతా వచ్చేస్తుంది సార్ బిస్కెట్లు వాళ్ళని తెప్పిస్తాం చదువుకోవాలి నీకు నీకు అందులో పడింది అది నేను దోమ ఆరంభం చేస్తాను నరసింహారెడ్డి గారు ఫోన్ చేస్తారు వైట్ కార్డ్ దొరకట్లా
మాకు సర్వాల్సి వచ్చింది ఆ లింక్ అనుకోవచ్చు ప్రెజెంటేషన్ ముందు అదే అన్ని తెలుగు కూడా అయితే లింక్
కొంచెం ఫంక్షన్ డిఫరెంట్ అలా చూసుకోండి ఒక్కసారి బేసిక్ సిస్టమ్ చూపించండి 5 మినిట్స్ అయిపోతుంది ఒప్పుకుంటే
వాళ్ళు ఇచ్చే నెక్స్ట్ మరి ఇలాంటి బాగుంటుంది.
ఇందాక ఏమైంది తెలుసా, పవర్ పోయింది
సార్ చెప్పండి సార్. సరే సార్, ఇక్కడే ఉన్నాను ఇక్కడే. సరే
సౌత్ ఇండియన్ స్టైల్
సరే ఎన్ని పెడితే బాగుంది కదా. ఏదైనా ఆఫ్లైన్ జరిగితే చక్కగా పెట్టేవాళ్ళు సార్, మనందరూ తినేవాళ్ళు.
అది మధ్యాహ్నం లేదు, 4 లింక్ 4 అయిపోయింటే లింక్ 5 లింక్ 3 లింక్ 2 యాక్టివ్ నా కోసం అక్కడ ఆపరేషన్ వచ్చు, థర్డ్ రైస్ కానీ ఆపరేషన్
ఇక్కడ బాగుంది, ఇక్కడ బాగోలేండి, ఇక్కడ మంచిదండి. ఇక్కడ బాగోలేండి, అదే సార్ ఇక్కడ బాగోలేండి, ఇక్కడ మంచిది. వంట అయిపోతుంది. నేనైతే ఇవాళ అయిపోగానే 6 గంటలకు మీ ఫోన్ స్విచ్ ఆఫ్ చేయాలి సార్. స్విచ్ ఆఫ్ చేసి సోమవారం రోజు వరకు స్విచ్ ఆఫ్ చేయాలి.
ఇంకా ఎన్ని ఇచ్చినా నాకు తెలియదు.
మీరు గూగుల్ మీట్ ఓపెన్ చేస్తే
గదిలో ఉంటుంది
అన్నిట్లో షేర్ చేస్తారు.
మీకు ఎవరి దాంట్లో పెట్టారు
మీ దాంట్లో మీకు స్క్రీన్ షేర్ చేశారు. అందరి దాంట్లో ఒకే
అందరూ స్క్రీన్ షేర్
అందరూ ఒకే ఉంటుంది.
పెట్టమన్నారండి మన ఎవరో
లైసెన్స్
అదే కదా అసలు వీడియో తీయటం నాకైతే రూపాయలు అనిపించాము
క్వాలిటీ ఉంటుంటే బెటరే కానీ అంత అనిపించలేదు. 5,000 అనిపిస్తుంది. 5,000 700 అన్నారు. ఇచ్చే రేట్ అయితే లేదు.
పక్కన పెట్టండి ఆడియో క్లారిటీ మా సార్ మాట్లాడుతూ నాకు ఇవ్వాలి.
సార్ ఆల్రెడీ స్లో మాట్లాడుతుంది. అట్లా కావాలి
వీళ్ళందరూ ఎక్కడ కానీ
అదే అందరూ షేర్ మీద సంబంధం కానీ మీరు రావాలి. తినేసి వచ్చాను
అది
మీరు ప్రజెంట్ చేస్తారా? అందరూ వస్తున్నారు
మీరు ఎవరు లేదు
మీరు మాట్లాడి చేస్తారా?
ప్రాక్టీస్
బాగా వచ్చాయి. 1000 వ్యూస్ ఏమో వచ్చాయి. మా ప్రోగ్రామ్ 900
అది వస్తారు సార్
కానీ చూసి ఎక్కువ దీనికే బాగా వచ్చారు. ఏది కల్చరల్కే ఎక్కువ
దానికి వస్తుంది కాకపోతే వీడియో క్లారిటీ ఉంటే సమ్మా ఇంకా బాగుండేది. వాళ్ళు మనకి పోయి చూపించే నాకు అది లేదు.
Nine 64 views.
అందులో ఖర్చు పెడితే వాడు లేదని చెప్తాను. మధ్యాహ్నం
యూట్యూబ్ ఆప్షన్ మేడం యూట్యూబ్ ఆప్ చేయాలా?
Good afternoon, sir. Professor Mahendra.
Good afternoon, everybody. Just a minute. Good afternoon.
Good afternoon.
Mr. Vinil, you are there? Hello, Professor Ramesh. Are you there now?
Yes, sir. Good afternoon. I'm there.
Good afternoon. Good afternoon. You can switch on your video.
Yeah. Already I logged in 10 minutes back.
Okay. Okay.
Good afternoon.
Good afternoon. So you can switch on your. Yeah. Nice to see you.
Yeah. Thank you, sir. Nice. Same from here.
So they have shown this lunch break. You know, it's a very sumptuous, very tempting.
It's Andhra meal. Andhra meal. Typical
Yeah.
Andhra.
Okay. Okay. It's very tempting. You know.
Rice, rasam, sambar.
Yeah. I would have loved to take this. And the conference is going very well. Means it's very nice. Professor Satyanarayana Reddy is he has worked very hard and it's a very good conference.
Yes.
What about Professor Reddy has joined or GVN Reddy? Professor GVN Reddy? Mr. Vinil?
Sir, Professor Sir, Mahendra Singh.
Yes.
Please announce that the paper authors they can confirm in the chat box so that we will have some idea.
Yeah. Okay. So
confirm their participation and presentation.
So all the paper authors, they are please requested, they can just simply write their paper number like TH13009 and etc. So they please put it in the chat box so that the chairman knows who are present. So chairman sir, you can note it down. One has come. You have to open the chat box.
09 has come.
Yeah, you can just you can take it. 09 has come. 1318 is come. Okay.
So first paper has come.
Yes. We will announce it at 2 o'clock once again because still we are minutes ahead.
Yeah.
And I think there was some delay in the last sessions also.
Yeah. For 34 has come.
34 has come.
And also you can announce when the presentation is going on, they can write the questions in the chat box.
So will you be able to note it down? All the chat, sometimes chat box is how
you can ask from the chat box only.
Okay. Okay. Then you have to decide whether you are going to take it at the end or just after the paper. Maybe
at the end is better.
You can decide it. Maybe one or two questions after the paper itself you can take.
Yeah. So the number of papers seems to be 1321.
So there are how many people? Still only 14 people are there. So let us wait.
It's a parallel session.
Yeah, obviously. So how many do we expect in parallel sessions?
Maybe 20, 25 up to 30.
Okay.
Because there will be some 7 panel sessions will be there sometimes.
Oh, yeah. One, two. So Professor Reddy is here or not? GVN Reddy, Professor Narasimha Reddy. Mr. Vinil, can you just check?
You must be having his number.
Yeah.
Vinil.
Vinil is the from the organizer's side. Hello, Vinil. Can you hear me?
Or Rakesh Reddy is there? Mr. Rakesh Reddy?
Someone from the organizer's side?
Narsim Reddy garu?
Good afternoon, sir. Am I audible? This is from admin.
Mr. Vinil, can you find it out Dr. Narasimha Reddy is there or not?
I'll check out and get back to you, sir, right now.
You can please talk to him on phone.
Hello, Anand.
Hello.
Sir, good afternoon, sir. Good afternoon, sir.
Good afternoon. ನಿಮ್ಮ ಪೇಪರ್ ಇದೆಯಾ?
ಸರ್ 2 ಪೇಪರ್ ಇದೆ ಸರ್.
ಮತ್ತೆ just put it in the chat box. One hack.
Yes, sir. I had put, sir, actually 10 and 18 are my papers, sir.
Okay.
So I am requesting it again. All the authors are requested to put their paper number in the chat box so that the chairman notes it down. We are going to start very soon. We are waiting for our co-chairman. Vinil, is there any update? Professor Ramesh, there are already 21 members, and I think 1 minute, I think we can wait, otherwise it becomes late. So,
We are trying to contact Narasimha Reddy, sir. He will be joining soon, sir, in time.
He will be joining?
In a couple of minutes, sir.
Okay, that's nice.
I'm trying to contact.
Professor Ramesh, shall I start? Because
Shall we wait for a couple of minutes? Let him come.
Okay.
Because he has already given consent.
So all those who have joined late, they are requested. The authors are requested to please give their paper numbers in the chat box so that the chairman notes down who are present. 1330 and 1324. 1330 and 1324.
సార్ మీకు నేను లింక్ పంపిస్తాను సార్ మీకు అందరికీ దాంట్లో మీరు మీకు మెసేజ్ పెట్టేస్తాను అది లింక్ చేస్తే లింక్కి వెళ్ళిపోతుంది ఎమ్మకి అలా తెలియదు మళ్ళీ లింక్ పంపిస్తే లింక్ వచ్చేది మీకే వచ్చింది వెంటనే వచ్చింది లోపల చాలా ఇవన్నీ కాదు లింక్ పెట్టి ఒకసారి
11 papers confirmed.
1, 2, 3. How many? 7.
7. 11.
Okay, in the beginning, you can just find it out whether the others are. We will keep announcing. Professor Reddy, are you there now?
Vinil, please confirm whether getting network or not. Already 6 minutes over.
Sometimes network problem is there, so.
పంపించారు లింక్ పంపిస్తాను నాకు వాట్సాప్ చేసి అది వాట్సాప్ ఉన్నారా ఉన్నా అది
Vinil, can you confirm, because already 7 minutes are there, so then we will have to rush. You know, we have to. This is for the information of all the presenters that we are going to select 2 best papers also, and those everything is counted in that selection. How you present, how you have organized, how you have answered the questions if the questions were there. So we have to do that exercise also. So you may kindly note it down, so that we are going to select 2 best out of the presented papers. Hello Balakumar sir, Namaskar, Mahendra Singh here.
How are you, sir?
Fine, sir. Thank you, sir. Nice to see you, sir. Nice to see you.
Hey, very excellent, sir. Very. It's a pleasure for me.
We always see you.
Sir, your paper is there, Balkumar?
No paper is here.
Okay.
My papers were over yesterday itself, sir. I had 2 papers with my VIT students.
Okay.
That is over yesterday itself.
You are in VIT, then?
Sir?
You are working in VIT or?
No, I'm an adjunct professor there. I take only the MTech students for thesis and some special topics I teach them, that's all. Whenever Dr. Chandrasekharan requires me to, he calls me to give some lecture for 3 days, 4 days, like that.
You are in NIT, no?
VIT.
VIT.
Where were you working?
Previously Institute.
Previously, where were you working?
No, I was working with Simplex Infrastructure, sir. I was, for 5 years I had been a consultant.
I know, a consultant.
Professor Ramesh, if you allow me, I think we can start. Then I can help you wherever you need. I can help you, sir.
Yes.
Okay. So let me welcome all of Dr. Narasimha Reddy is here. Welcome, Professor Reddy. So
9 minutes left.
Good afternoon. There was a link problem.
Yeah, that's what I was expecting. So let us quickly start. And friends, we are now reaching at the almost the end, and I should not say end, but towards the end. And it is the theme number 13, technical session, and it is on tunneling and deep excavations. Very important topic, because a lot of infrastructural activities are going on, lot of tunneling and all these activities are going on. And we have 2 dignitaries here who will be handling this session. We have Professor H.N. Ramesh with us, who will be acting as chairman, and I'll be reading very brief. Professor Ramesh is presently working as Principal University Vishwasriya College of Engineering. Formerly, he has been Vice Chancellor acting, formerly Dean of Engineering of Bangalore University. So he has held so many prestigious positions, and he completed his BE Civil from GVTT College of Engineering in the year 1984 and PhD from Indian Institute of Science, Bangalore. He started his career as a lecturer in civil engineering at SJJIT in the year 1984, and then he has served as a geotechnical consultant with Secon Surveys, Bangalore during 94-95, and as senior geotechnical engineering in Tata Consulting Engineers during 95-96. Then he joined University Vishwasriya College of Engineering as a reader in soil mechanics and foundation engineering in 1996 and was promoted as a professor of civil engineering in February 2004. He was the chairman of Department of Civil Engineering UVCV during 2010 to 2012, and he has so far supervised 15 PhD students, more than 70 MTech thesis, ME thesis, and he has published large number of papers in refereed international journals and conferences, more than 160. Sir, I'm cutting it brief now. So he and he is a very good friend. Means he's a very in the sense that I know him personally, as we have interacted in the executive committee. A very dedicated person, and very simple at heart. So this is very brief about Professor Ramesh. Now we have welcome, Professor Ramesh. So I'm cutting it short. It's your CV. And also, we have friends here, Professor G.V. Narasimha Reddy. He is Professor of Civil Engineering at JNTU Hyderabad. He did his BTech from REC, now it is called NIT Warangal, and MTech from KREC, NIT K Surathkal, and PhD from JNTU Hyderabad. And he has more than 20 years of teaching and 2 years of construction and design experience, so very rich experience. And his research interests include whole gamut of geotechnical engineering. He is very actively involved in pursuing research on reinforced soil and geoenvironmental engineering. He has guided 2 PhD theses and more than about 30 master theses, and he has completed very good research projects. More than 50 lakh of rupees he has generated as a research grant, and very I'd like to say, it's very proud to say that he is instrumental in establishing the Center of Excellence in Disaster Management. These are the needs of the day. So where he is the principal investigator. So again, without going in detail, I am now handing over the session to these two dignitaries, and I request the presenters to please confirm in chat box your paper number, or the chairman then can decide how much time you have to take for presentation, and maybe it is the decision of the chairman whether he allows the question answer just after the paper or he allows it at the end. You can put your question in the chat box as per his decision. So, sir, Professor Ramesh and
Thank you, sir. Thank you very much for your nice words for the chairs and co-chair, chair and co-chair. And thank you very much. I know Professor Mahendra Singh since 2 decades. By the time he was working in, both of us are very close actually. And my PhD, the ME students, he helped me with some study material because
I forgot to mention that he is very eager to learn. He is very eager to learn, and he had
very strong in rock mechanics. I'm really impressed by his approach. I'm very fortunate to have interaction with since two long decades. And at the end also we'll allow the overall if anybody is interested. Okay, now we'll start the session, and I request our co-chair Narsimha Reddy to maintain time and summarize at the end.
Okay, sir.
Then I'll call upon the first paper, TH 13009, numerical study on the influence of in situ stress ratio on stress and deformation characteristics of rock tunnel by Jagdish Kumar T and Mutta Ram. Who is there? Jagdish is
Hi,
there?
sir. Hi, yes, I'm here, sir.
Please start your presentation.
Okay,
Please
sir.
finish your presentation to maximum of 6 minutes.
Okay, sir. Is it visible, sir?
Yeah, you are audible. Please continue.
You need
Is it
to
visible,
click
sir?
on
The
present.
PPT?
No. Please click on the present now
PPT is
option.
not visible.
Okay, sir.
On the bottom right side of your screen, you can see present now option.
Now, sir?
Yes. Now your screen is being presented.
Okay, sir. Thank you, sir. Good afternoon, everyone. Today I'm going to present my project titled Numerical Study on the Influence of
And
In-situ Stress
Mr.
Ratio
Jagdish
on
Kumar
System.
and other participants, sorry for the interruption. I once again
Okay, sir.
repeat, two best papers will be selected by the chair and co-chair, and depends on how you present and your question, how you answer the questions, etc. So you please present seriously, and also the award also will be decided on the time. For 6 minutes, you should not take 10 minutes. So all of you, please restrict to 6 minutes. Wish you all the best. Thank you.
Thank you, sir. My project title is Numerical Study on the Influence of In-situ Stress Ratio on Stress and Deformation Characteristics of Rock Tunnel. In introduction, rock at the depth was subjected to stress because of the weight of overlaying strata, tectonic plate movements, soil erosion, construction of building, etc. An excavation or opening in a rock may disrupt the stress field, and new set of stresses are induced in the rock opening. In this study, the three different shapes of the tunnels are analyzed: circular, elliptical, D-shaped, and different in-situ stress ratios 0, 0.5, 1, 1.5, 2, 3 are considered. In-situ stress ratio is nothing but the ratio of horizontal stress to the vertical stress. As it is difficult to perform an analytical study by creating models and applying stress values, the study has been performed numerically by Plaxis 3D finite element software. I have used two different models, Morcoulomb and Hook and Brown models, and I have compared the result based on the deformation and stress values. In the second picture, you can see that how hoop stress and radial stress act on the wall of the tunnel. And then these are the literatures that I have go through it. And based on this literature review, I have adopted this methodology. And first I have selected a Charnockite rock for the analysis, and I have chosen two models, more cool model and a Hook and Brown model for the analysis, and I have used Plaxis 3D for the numerical analysis. And I have very different in-situ stress ratio for three different shape of the tunnels. For two, and I have analyzed based on two different models. Based on the results obtained, I have plotted the graph, and they are discussed below. This is the properties of the rock. The first tabular column shows the Hook and Brown parameters and their values. Second tabular column shows the more column parameters and their values. These values are I have obtained from the literature done by Arimos et al. And then validation. Coming to validation, application of this model is verified by the published result of Singh in 1985, in which circular tunnel is analyzed by coupled FEBA method. These are the properties of the rock he used for analysis. And the second tabular column, you can see that the second column, these are the result he have obtained through this analysis. And third column, you can see that the result obtained by me through FEM through Plaxis software. The results are more or less same, but the differences may be due to he analyzed using FEBA method, and I have analyzed using FEM method. And the picture shown below is the Plaxis, one of the Plaxis result for the in-situ stress ratio k is equal to 1 for this validation. And coming to the result, the mesh size I have taken for the simulating the model in Plaxis is 24 into 24 into 24 meter. It is same for all the shape of the tunnel, and the center of the tunnel is fixed at the depth of 12 meter from the surface. Then this is the more column Plaxis models that I have simulated in Plaxis 3D, and for different shape of the tunnels. This is first picture shows that for a circular tunnel, second picture is for elliptical tunnel, and third picture is for D-shaped tunnel for in-situ stress ratio 0. based upon the Plaxis result, from the displacement values I have obtained, I have plotted a graph between displacement versus in-situ stress ratio for 3 different shapes. From these graph, you can see that with increase in-situ stress ratio, the deformation at the side wall of the tunnel get increases. But when coming to the deformation values, more Coulomb gives more conservative results, because as you can see in the first graph that the deformation and the side wall and the roof are more or less same. While comparing these 3 graphs, these 3 shapes, elliptical tunnel shows more deformation when vertical stress is high. As you can see in the second graph that elliptical tunnel shows more deformation when in-situ stress ratio is zero. This is because of the height to width ratio. As the width of the tunnel is higher than that of the height, when vertical stress is applied on the top of the tunnel, the deformation will be more at the roof when comparing to the when horizontal stress is applied on the side wall of the tunnel. From these three, elliptical tunnel shows more deformation when in-situ stress ratio is zero. With the help of the stress values, I have plotted the graph for radial stress and hoop stress. From these 3 graphs, it is concluded that with the increase in situ stress ratio, that plastic zone or stress concentration or radial stress and hoop stress will be more at the roof of the tunnel. That is because if the deformation is more in top of the tunnel, the plastic zone or stress concentration will be more at the side wall. When the deformation moves towards the side wall, when in-situ stress ratio increases, the plastic zone and the stress concentration will be moved towards the roof of the tunnel. While comparing the radial stress and hoop stress, the hoop stress values are higher when compared to the radial stress. And in third chart, you can see that the hoop stress increases up to the 2 times the dia and then get decreases. And then the pattern, these 3 patterns are followed for all the shape of the tunnels and for hook and round model also. But the stress values are higher for the hook and round model. And when these are the Plaxis results for the hook and round model for 3 different shapes for in-situ stress ratio 0. And based on
5 minutes are over.
Okay, so okay.
Finish in a minute, right?
Here you can see that the difference between the hook and round and Moore-Coulomb model. Here the Moore-Coulomb model, in Moore-Coulomb model, the displacement results are the difference are very small. But in hook and round model, the difference are very much when in horizontal and vertical. In vertical and horizontal displacement. And while here also the elliptical tunnel shows more displacement when compared to the other 2 shapes. And while coming to the total displacement, first chart shows that the total displacement of the elliptical tunnel is more when compared to the other 2 shapes. And in second chart also the total displacement of the elliptical tunnel shows more displacement when compared to the other 2. And while combining differentiating between Moore-Coulomb and hook and round model shows more total deformation when compared to the hook and round. From these results, I have concluded that the Moore-Coulomb results give a more conservative result, because the strength envelope of the hook and round is not a straight line; it's a curved path. So it gives a low strength estimate than the Moore-Coulomb model. The results applied clearly shows that increase in in-situ stress ratio, the deformation at the side wall going to be increased. When coming to the total displacement, elliptical tunnel shows higher deformation, so that if there is a need of providing a elliptical tunnel, a proper support system like vaulted support can be provided. And when coming to the D-shaped tunnel, a D-shaped tunnel suffers high stress concentration at the sharp bends. That is, critical stress concentration increases as the boundary relative radius of the curvature decreases. Therefore, the opening with the sharp corners should therefore be avoided. And proper support system can be designed with the help of the ground response curves also. These are my references. Thank you.
Thank you. There are no questions in the chat box. We'll go to the next presenter. TH1310, numerical study on prediction of behavior of braced excavation in heterogeneous soil by Anand, MH, Pankaj, B, Gotakindi, DS, and Solanki, CH. I think Anand is there. Please, Anand, you please restrict your presentation to 6 minutes.
Okay, sir. Fine, sir.
Co-chair will be noting on the time.
Sir, my slides are visible, right?
Yes.
Okay, I thank Professor H. N. Ramesh sir, Professor Mahendra sir, and Reddy sir for giving this opportunity. And my topic is numerical study on prediction of behavior of base excavation in heterogeneous soil. This was work of one of my student during her master's thesis. So I am presenting on behalf of my master's students work. So these are some contents. As we know that deep excavation has become very common in metropolitan cities, especially nowadays we are seeing that a lot of damages are occurring at the adjacent structures because of the deep excavations. So one has to study this system, the deep excavation system, very thoroughly, and with respect to the numerical modeling and other things. We need to study the behavior of deep excavation and different retention systems. We need to go through that. And recently, all of you know that there was a failure of complete system of deep excavation in Bangalore near Kapali Theatre. So it occurred on July 29th. So where he has constructed diaphragm walls at three sides, and one side he didn't go for the diaphragm wall, and nearby two buildings were collapsed completely because of the negligence of the contractor. So this had come in the news, and it has become a big issue. So I had given a link over here, so we can just go through the link and for more details and all. So this is the reason, one of the main reason one need to study the deep excavation thoroughly. And in this particular study, these are my these are our objectives. First thing is to actually make a numerical model which has to be validated with the available literature, and different embedment depth to the depth of the excavation ratios are considered to study the behavior of the diaphragm wall. So diaphragm wall is considered as a retention system here for excavation, and different D by dB is nothing but depth of embedment, and D is the depth of excavation ratios are considered. dB by D ratios are considered to evaluate the lateral wall displacements, then vertical settlement of the ground behind the excavation, then extreme or lateral and vertical settlement. Those things have been calculated. And these are some soil parameters which has been considered. So this is a some part of the work of my students. So where different soil stiffnesses are considered from top to bottom with different SPTN values, so that we can understand the nature of the soil stiffness also. And we have considered different dB by D ratio. So dB by D ratio 0.4, 0.8, and 1.2 and 1.6 have been considered. And depth of excavations are considered as 5 meters, 10 meters, and 15 meters. And based on these depth of excavations, different embedment depths have been considered. And these are some results which you can see, validation results. So with respect to some field observation data and SEONG literature, even field observation is from one of the literature. So present study is shown here. So it is almost well in agreement with the literature what we have. And these are the different depths of excavation. As I said, the 15-meter excavation has been carried out in 5 phases. 10-meter has been carried out in 3 phases, so on. And these are the some study of parametric study what we had conducted. So lateral wall displacements for different dB by D ratio from 0.4 to 1.6 have been shown here. And this one is for 5-meter depth of excavation, and this is for 10-meter and 15-meter depth of excavation. So we can see that the wall deformation with respect to the depth of the excavation. And similarly, we can also see the vertical settlement of the ground near the excavation or from the face of the diaphragm wall and across the model, the numerical model, for different values of dB by D ratio. So has been shown here. So we can see that one thing that's nothing but when our ratio is very high, so when the depth of excavation is more, and we see some little higher settlements compared with the lesser depth of the excavation. So in conclusion part, I'll discuss about those things, and these are some behavior of a wall at the different excavation levels. For example, when we are going for only wall and load, when we insert the wall and load, then when we go for the first level of excavation, second level of excavation, then these are the some results we see. Okay, so wall deformations for different cases. And here also we see that this is for again different ratios of dv by d and depth of the excavation. So this one is for 10-meter excavation what we are seeing, and these are for 15-meter excavation. And basically as we see here, the depth of the dv by d ratio have been considered 0.4, 0.8, 1.2 and 1.6. And as we see that at the excavation 2 and 3, the deformations have been observed on the higher side because of more deeper. When we go more deeper, then we have a very less stiffness soil which is present at the top, and because of that, we might have got little higher values of wall deformations. And since I have a very less time, so I want to conclude as soon as possible. So as we know that as the depth of the excavation increased, wall deformations were increased, and with the increase in soil stiffness, we are going to have some little more pressure on the wall. Some results were in the optimum results were obtained for dv by d ratio of 0.8. And in case of depth of excavation of 5 meters, we found that there is an increase in wall deformations, and especially even there is some decrease in the vertical deformations. And in case of 10-meter and 50-meter, both lateral wall displacement and vertical wall displacement, they kept on increasing, so that with increase in the depth of the excavation. So these are few observations what we had seen from this particular study. We can have some retention systems like these are the some remedial measures which we can give as a remedial measures which people are using in the practical applications in most of the cases. So these are my references. Thank you one and all. Thank you.
You have to unmute.
So, yeah, there are some questions.
Professor Ramesh, you have to unmute. Professor Ramesh, you have to unmute. Your mic is muted.
Okay. Anand, over?
Yes, sir. Yes, sir. I'm done, sir.
Okay, next presenter, 1313. Paper number 1313. Kings of Dawn.
Anand sir, please stop presenting your screen.
Hello? Please present your paper. Okay. Paper number 1313.
1313 is present or not?
Yes, I am here. Please continue. Please present.
Is it visible?
Who is presenting?
Kingshuk Dan. I'm Kingshuk Dan. Is it visible?
Yeah, please present. You are audible. Please take 6 minutes.
Okay, thank you. Good afternoon to everybody. Myself Kingshuk Dan from Coachbihar Government Engineering College, West Bengal. Today my topic is active earth pressure distribution against breast wall considering arching effect. Now, breast excavation is the kind of deep excavation, and in recent decades, breast excavation is widely used.
Say a bit loudly, so it's not audible, sir.
Okay. Breast excavation is a kind of deep excavation, and breast excavation is widely used in the for the construction of underground facilities in different kind of soil, and it is favored because it is less expensive, construction is simple, and involves less specialized equipment. Breast excavation is usually used in heavily built-up areas for construction of underground facilities, and like any kind of deep excavation, breast excavation also causing some ground movements, and any structure which is lying within the zone of influence is likely to be affected. So it is very necessary, it is very important to properly predict ground deformations, and properly prediction or adequate prediction of active earth pressure is another major considerations because it is related to ground deformation. Traditionally, civil engineers uses rankings of Coulomb's earth pressures to estimate earth pressure distribution against rigid retaining wall, but this kind of earth pressure distribution is linear, but in practical cases, non-linear distribution is observed. And this depends on different parameters like wall movement, friction mobilization between soil and wall rigidity, spacing of lateral support, etc. Arching, consideration of arching is also necessary. Arching is nothing but stress redistribution or stress is transferred from yielding part to adjacent stationary part. In this paper, a formulation for calculating active earth pressure on a braced wall, considering arching effects, is presented, where effect of cohesion, angle of wall friction, or angle of shearing resistance are used. Thus, we can use this formulation for both cohesive soil and cohesionless soil. We have separately analyzed for above excavation or below excavation. Now, regarding literature review, I have already said that there are so many literatures are there. Previously, this kind of artificial distribution models are presented by Coulomb's, Rankine, Pejegi, and Peck. But the most of the cases, linear artificial distributions are provided. In latter cases, Hamby, Pike, Salgado, Goel, Patra in 2008, or Rao et al. 2016, and many more researchers provided the artificial distribution which is nonlinear type. But in the most of the cases, the soil is taken as a cohesion-less type of the soil and wall undergoes translation. In my present study, some considerations are taken. At first, the slip surface. The slip surface depends on mode of wall movement. The mode of wall movement may be translational, rotation about the top, rotation about the bottom. When translational wall movement is there, the planar slip surface is observed. When rotation about the top, then curved slip surface which makes an angle 90 degree with horizontal is observed. So in these cases, above excavation, translation along with rotation about the top, and in bottom below excavation, rotation about the bottom is considered. And combining all these, we can take planar silk surface which makes an angle 45 degree with 5 plus 5 by 2 with horizontal. Now, deformation pattern is another important factor. In my cases, above excavations, the spandrel type deformation is taken into consideration. This is happening when the large wall deformation is occurring prior to installation of the first strut, and in subsequent stages, the small wall deflection is there. In second, is there. So, in these cases, I have taken the spandrel type deformation or maximum wall ground deformation is occurring just next to the wall. In these cases, the similar kind of arc-shaped ground deformation is presented here. The trajectory of the minor principal stress is follows an arc of a circle, and which makes an angle 45 degree plus 5 by 2 with the slip surface at right edge of the slip surface, and major principal stress makes an angle psi with the vertical, which is 0 at the right edge, and theta at the left edge. And for below excavation, the maximum ground deformation occurs at some distance behind the wall. This is because the maximum, for final stage of the excavation is performed. Before that, multi-level start is installed. For that, the maximum deformation occurs just some distance behind the wall. So here, the concave type of deformation is taken into consideration, and a similar type of arc-shaped ground deformation is considered. The trajectory of minor principal stress is following in the tangential direction of the arc-shaped ground deformation, and it is horizontal in the center, and the major principal stress makes an angle theta 2 with the horizontal, which is psi 2 with horizontal, which is theta 2 at the left edge, and 180 degree minus theta 2 at the right edge. Now I have performed the analysis for above excavation and below excavation. You can see these formulations. This is taken for a soil element which is adjacent to the wall, and we have taken the lateral stress at the wall, which is sigma hw1. We have presented the equations, and similarly horizontal stress at any point as considered. Here the psi replaces the theta value, theta parameter. Okay. Now I have drawn the Mohr circle diagram, and from that I have calculated presented the expression of shear stress and theta, and from that equation we can get to unknown parameters, that is n, which is nothing but the ratio of major principal stress and minor principal stress, and m is nothing but ratio of adhesion and minor principal stress. Now I have taken the differential flat element which is at a distance z below the ground surface and width of which is Bz1. The average vertical stress on this differential flat element is not uniform because arc-shaped deformation, and it is F1 by Bz1. F1 is the total force coming on this element, and solving this I have got the average vertical stress which is shown here, and now finally get the lateral arc pressure coefficient at the wall, which is KAWN1, which is nothing but sigma HW1 by sigma V1 bar, and the expression is shown here. Now I have performed the force equilibrium equation in the vertical direction for this differential flat element, where in the vertical direction sigma V1 stress is acting in the downward direction, and sigma V1 plus d sigma V1 stress is acting in the upward direction. Shear stress is also acting in the upward direction, and the weight of this element is gamma B01 into dz is acting in the downward direction. And solving this differential equation, I have got the horizontal stress or the active earth pressure distribution. By performing solving this equation or putting the values in this equation, we can get the earth pressure values below the ground surface. This is applicable for above excavation. Here C01 C0u is the initial cohesion and C1u is the increment rate of cohesion. Now, similarly, the similar analysis is performed for the below excavation. We can see that the sigma HW2, that means the earth pressure lateral stress at the wall, and the sigma H2, the lateral stress at any point, and simultaneously considering the Mohr circle diagram, the shear stress and the theta2 value is presented there. Now, similarly, the earth pressure coefficient for below excavations, so similar analysis we have been done, and the only thing is different is from the previous cases is that the earth shape is different, it's concave type. And now finally we get the sigma HW2 for the below
Excuse
excavations.
me, almost 6 minutes are over. So try
Okay,
to.
okay. So this is the lateral stress distribution for the below excavation, and solving this we can get the equations of the earth pressure distribution. Here L1 denotes the depth of cut and Z is depth starting for the excavation length. Now to validate, we have considered three case studies. It is reported in the literature. The first is in Kolkata Metro construction, where excavation depth is 14 meters, supported by 600 millimeter diaphragm wall, and the soil is soft clay type, and we presented the depth of the earth pressure distribution with depth on ground surface. And from this a plot, we can see that the predicted value is very close to the measured value. Similarly, we can do another two examples. This is for
Please wind
an
up.
idealized deep excavations. Okay, and this is for cohesionless soil, and you can see the results. And similarly, this is another expression. This is for soft clay stand height. Okay. The final conclusion is, as these equations can be, this is included both cohesion and angle of shearing resistance, so these can be used for both cohesive and cohesionless soil. The separate analysis is done for above excavation and below excavation, so a deep seated excavation is considered here, and this is my references. Thank you.
Okay, thank you. Next presenter, 1315, paper number, investigation on actual response of soil due to state channeling, a numerical approach by Manoj S, Abhishek R, and Sawan. Abhishek is presenting. Okay, please take 6 minutes quickly.
Yes, sir.
Time is
Okay, sir,
running.
sure, sir.
We are running short of time.
Abhishek,
Okay,
after
sir,
5 minutes, I will give a ring like this. Right?
Yeah, okay, sir, sure, sir. Okay, sir, sure, sir. Thank you, sir. Okay, sir. Very good afternoon, everyone. Our topic is on investigation on axial response of pile due to stage tunneling and numerical approach. Like these are my contents. I'll go to the next slide. Okay, the introduction. Like we know, in the current times, like the metro tunnel works are going on like so and so, 4 and 4. Like we all know about the construction sequence of tunnelers. Like we go always for the precast concrete liners. Like we keep on like shifting concrete liners from one point to the another, like in a regular tunnel interval, so that like we make the tunnel construction sequence at a faster rate. And then this is my introduction. Like we always know that like the superstructures with pile foundation are highly vulnerable due to the stage tunneling process. Like whenever like we go for the deep excavation, the superstructures get affected to a great extent. And also like whenever the length of the pile foundation is increased, there also occurs a very big zone of influence of tunneling is also occurs. And also the initial pile segment analysis also, it also plays a major role. And what we have did in our major part is like we have validated a numerical paper and also an experimental study. And our work is on using the numerical software Practice 3D. And these are the structural. This is a sample picture of the structural failure that caused due to the process of tunneling. And this is what we have validated experimental. Like we had one experimental study that we conducted in our institute. A prototype of 2 meter plus 2 meter plus 1.5 meter. Like we made a very big rectangular cube, and then like we filled the soil and then with the different varying relative densities, and then like we used a technique called stage fluid extraction technique, like to incorporate the process of tunneling. And like we measured like this construction sequence like from volume loss from 0 to 10%, like, and then we used the corrosionless soil medium. And then like whenever when we're validating this experimental results with our numerical values, there was some like variation of 4 to 6 percentage of results. And then like we were validating the Lee et al 2016 the numerical paper, which used the double O tunnel model, also with an equivalent diameter tunnel model. So we were validating, and then whenever like we found when we compared our results with the experiment with the results obtained from Lee et al, like it was like some 2 to 3 percentage variation was observed. And then the soil model which they were using is small strain hardening model. And also the type of these are the material properties that which we incorporated. We use the type of soil as like hardening soil model, and then drainage condition as drain DA, and then the unsaturated unit weight as 16.6, and then the saturated unit weight as 17.7, and so on it goes on. And then these are the material properties which we are using: the plate, the concrete liners, and then the pile material. And then I have mentioned all these properties, and then I'll go to the numerical modeling. I've used the numerical the finite element software Plaxis 3D for my investigation. So what we are doing initially is like we were like fixing with the help of the borehole option, like we were making the soil profile as 150 cross 52 cross 48 meters. And then like we used hardening soil model as a constitutive model for the numerical analysis. And then we fabricated a circular tunnel of 4 meter in diameter in the modeling. And then like we varied the volume losses like from 0.5 percentage, 1 percentage, 1.5, and 2.5 percentage. And then we were like seeing the effects happening because of each and every volume loss. And then like we were manipulating the results based on that. And these are the numerical modeling what we have did. Like in our process, like we separated our analysis into two parts. Like the first one, like what you say, like the greenfield condition, only the soil and pile. Like we inserted the pile, and then like we measured the pile settlement, like how much how much it settled during its installation. And then the stage construction of tunnel, that is like we had a 150-meter tunnel, and then like we divided into three parts, like not three parts, like a tunnel of interval of 3 meter, like 3 meters, like we were dividing. And then like for each and every sequence, like how much rate of settlement was occurring was our main measurement. And then like we were varying our pile location, that is crown, the central line of the tunnel. And then like 2D distance, 4D distance, 60 distance. Like here this D represents the diameter of the tunnel, which we have taken as 4 meter. And then like we took two cases of pile length, like 8 meter length, 8 meter pile, and then the 60-meter pile. Like the whenever like we go for the behavior of the pile, like when we considered a critical depth, our critical depth came around like some 10.5 meter. So this 8-meter pile like very like a linear one, and then this 16-meter pile went for a multi-linear one, like till 10.5 it was like linear, and then like it was flat after 10.5. And then like we were like imposing working loads like 512 kilonewton, 1778 kilonewton, and 3537 kilonewton on the pile head. And then after that we were taking the tunneling sequences. And this is a numerical model. Soil profile indicate this figure 3. It represents a soil profile indicating the greenfield condition, that is without tunnel. So it is of like 150 meter cross 52 cross 48. And then this is my structures mode, which I have represented like the tunnel, and followed by the positive interface also with the pile. Like this pile is at the ground surface. Like similarly, like we have moved it to 2D distance, 4D distance, and 60 distance. And these are my results and discussions. Like the effect of pile head settlement, like what happened to the pile spacing. Like I have represented the crown as 0D here, and then 0D, 2D, 4D, and 6D. So which represented like whenever like I was going for a lengthier one, the settlement got decreased. That is whenever the pile was on the ground, a huge rate of settlement was there. So which indicates that the superstructures with piles should be located at least far apart from the tunnel center line. So like as far as like we come closer to the tunnel center line, the greater the damage occurs to the pile. And also like the maximum settlement of the pile head is 0.703 percentage of the pile diameter for a pile located at the ground. And then like we were identifying a clear zone of influence. And then like whenever we are influencing right from the tunnel center line, like from minus 3D to plus 3D, right from the tunnel center line, like we are finding a zone of influence. And also the effect of volume loss, like this volume loss, which is also known as the contraction loss, which was occurring like whenever we are doing an excavation, like a certain loss of soil was also accompanying on the side by side. So which it also influenced the rate of pile head settlement also. Like whenever this volume loss was increased, the pile head settlement also increased linearly. So we have plotted like 0.5 volume loss, 1 volume loss, and then like 1.5 percentage of volume loss, and 2.5 percentage of volume loss. Like in this, which we have observed that the 2.5 percentage of volume loss, in this case the pile settlement mode, like irrespective of the spacing, like whether you have the pile at the ground 2D, 4D, 60, like whenever we had these cases, like the settlement was greater when we had the volume loss of 2.5 percentage, and then the effect of pile length, like we had like two pile, like as I mentioned earlier, like we had two pile lengths, like 8-meter one and the 60-meter one. So which indicates like whenever like we increase the length of the pile, the rate of settlement also increased, and also the drag force that we obtained is always it was also proportional to the surface area of the pile with the zone of influence of the tunnel excavation, and also the settlement varied non-linearly with volume loss of the tunnel and the rate of settlement observed to increase with the volume loss of tunnel. And then the effect of working load on pile, like as I mentioned earlier, like we used like three working loads, like 512 kilonewton, 1778 kilonewton, and 3537 kilonewton on the pile during tunneling. The factor of safety 1.27 is recommended after tunnel construction. Higher the load, higher the rate of settlement was occurring here and there. And then I would like to conclude like in a very crisp way. The settlement of pile increased whenever the volume loss increased, and then like we found a zone of influence, like a zone of 5 times the diameter of tunnel ahead, and then 7.5 times beyond the pile location has been identified. And then the lateral influence of pile settlement has been extending up to 6 times up to the diameter of tunnel on the center line. And so the pile settlement varies linearly with the lateral displacement of pile location from the tunnel axis. That's it, sir. Thank you.
Thank you. Thank you very much. There are no questions in the chat box. So let us move
Okay.
on to the next paper. Uh,
Okay.
1316.
Yes, sir. Thank you, sir.
1316 by a comparison of limiting equilibrium and finite element analysis for embedded retaining walls by Tehsina Ali and
Yes, sir.
Azina KM. Who is
Yes, sir.
presenting? Tehsina Ali. Please present and you please take
Tasina.
6 minutes. Yeah, please take
Yes,
6
yes,
minutes. Okay. Start your presentation quickly.
yes, yes, sir. Good morning, everyone. My name is Tasina Ali, and the topic of my presentation is comparison of limiting equilibrium and finite element analysis for embedded retaining walls. When we talk about embedded retaining walls, it comprises of sheet pile walls, secant pile walls, diaphragm walls, etc. And the design of these retaining walls is a part of classical geotechnical engineering, with limit equilibrium approach as the most common approach. At the same time, finite element analysis provides several advantages, and tendency to use finite element method is increasing. So in this particular study, the analysis of cantilever wall, single propped wall, and multi-propped wall is done, and results between limit equilibrium approach and finite element method were compared. So the main uh, aim of this study is to compare the results of limit equilibrium approach and the results of finite element study. The finite element analysis here was done in Plaxis code, and soil was modeled as Mohr column. So the first one is cantilever wall analysis. A typical cross-section of cantilever wall is illustrated here in figure, and also the Plaxis input parameters are provided in the table. So these figures shows the comparison of earth pressures and bending moments. It was observed that active pressure as per Plaxis is almost matching with limit equilibrium pressure. But in the passive side, they match in the beginning, while Plaxis value reduce later. As for bending moment, the values almost match. That is the values of limit equilibrium and Plaxis, they almost match. So the second case was single propped wall. A case study of CMRL, that is Chennai Metro Railways, that was considered for the analysis of single propped wall. So soil profile along with the level of excavation and prop is shown in figure. Plaxis input parameters are also presented in the given table. So a comparison was made and it was observed that in case of Plaxis, an increase in active pressure at top and decrease in active pressure at bottom and decrease in the pressure below drop is observed. Also, in a passive state, the plexus earth pressure decreases as it moves towards the toe. The table here it tabulates the results from both analyses. The factor of safety from limit equilibrium analysis was 1.8 and from Plaxis it was 1.7. Bending moment was 125 and 95 respectively, and strut force was 1287 kilonewton and 1395 kilonewton respectively. So this one is multiple propped wall. It was constructed stage by stage and it was taken from Syria SP95. The soil profile and the level of rocks and excavation is shown in the figure. Plaxis input parameters are also presented here. So the earth pressure diagrams here are like that of the single propped case with Plaxis results showing some variations from limit equilibrium earth pressures. The table here tabulates the results of prop loads and bending moments and compares them uh, from limit equilibrium results and Plaxis results. So the main conclusions drawn here are that in case of cantilever wall, active pressure as per Plaxis is almost matching with the limit equilibrium pressure. In the passive side, the Plaxis and limit equilibrium values match in the beginning and the Plaxis value reduced later. As for bending moment, the values almost match. In case of single propped wall, an increase in active pressure at the top and a decrease in the earth pressure below the prop is observed for Plaxis result. The Plaxis earth pressure decreases as it moves towards the flow. So in case of multiple propped wall, the Plaxis earth pressure shows some variation from limit equilibrium pressure. So the study indicates that for certain circumstances, horizontal stress, bending moment, and prop force may be higher than those predicted by conventional techniques. So these are the differences, and that's all from my side. Thank you.
Okay, thank you. The next paper is 1318. Assessment of effect of deep excavation on adjacent structures using finite element analysis by Anand MH, Solanki CH, and Dodagoda GR. I think Anand will present. Anand, please restrict your presentation to 6 minutes.
Thank you, sir. Thank you, sir. Uh, so just assessment of deep excavation or adjacent structures using finite element analysis. These are some contents and introduction. I had already mentioned in the previous lecture. So this was one particular need of the study, which I just spoke about, like the need of study. Like if we don't consider the proper analysis in deep excavation, then how it is going to affect the adjacent buildings and how it is going to collapse the adjacent buildings. So this is where these kind of studies are required. So that is why I have taken the topic like assessment of the deep excavation on the adjacent structures. So basic objectives, I have kept it very simple. So here I'm going to study the stiffness of the support. So we are using some support stiffnesses, anchors or tie back anchors. So what we are using, how this stiffness is going to affect the bending moments and lateral deflections, and if you have some ground outer conditions or maybe neighboring distance from the face of the wall, something like that. So these are the some parameters which we consider for the anchors and the diaphragm walls, and basically which is connected to anchors, and this is the load, the adjacent structural load which we are considering in our study. And these are some results which I'll be discussing now. So here what we have done is we have considered two different soil models. One is Moore Coulomb model and the other one is the hardening soil model. And these are the results like this. And here we have considered the four different diameters of the pile, and contiguous pile wall has been uh, analyzed, and these are the four diameters of the pile. So pile zero point 0.4, 0.6, and 0.8, and this is where we are seeing the maximum bending moment of the soil. and there are four different load types are there. So these are the L1 to L4. These are the different load types for different more column and hardening soil model. And for different anchor spacing, so whatever the anchors we have used, for the different spacings of the anchor, how the bending moment, the maximum bending moment we are going to get. So that is what is studied here. As we see that, when the spacing is very less, so we have a very less bending moment compared to the higher spacing. So this is what we see for both more column model and hardening soil model. And we can see also one thing, for example, one is the spacing of the anchors. The other one is if I change the pre-stress force from the anchor, so from P1 to P4. So these things have been changed, and the depth, with the depth, the deflections have been, the wall deflections has been studied. So these are the different cases for different cases for P1 to P4. So P1 presents the anchor pre-stress force for the first one, and P4 presents the anchor force for the last one, that is 662 kilonewton per meter. And as we see that, when we have a more force, then we are going to have some more deflections and other things. And more Coulomb model, actually the soil modeling is giving us the higher deflections, higher deformations compared with the hardening soil models. The other one we can also see here, if I get the wall bending moments, okay, the wall bending moments with the depth, and also pre-stress for different pre-stress forces. So here we can see four different forces, P1 to P4, and this is for more Coulomb model, and this one is for hardening soil model. And with the depth, again we are going to have different deflections, and again what we see here is for greater shear force. Okay, so the deflections what we have, the bending moment what we have got is lesser compared with the other thing. So these are the few things, and there's the attempt has been made to compare the hardening soil model and the more Coulomb model also. So where we have just compared for the same deep excavation problem, comparison is made between hardening soil and more Coulomb model. This is the graph which is showing the bending moment along the depth of the excavation. The comparison between the more Coulomb model what we are seeing and the hardening soil model. As I said, we have got greater bending moment, higher bending moment for the hardening soil model. For the more Coulomb model compared with the hardening soil model. And similarly, we can also see the vertical wall deformations. Vertical wall deformations with the depth. Again, we can see there's a change of 0.03 meters deflection for more Coulomb model and the hardening soil model. So these are some observations we could observe from this particular analysis, and some conclusions. As I said, maximum lateral wall deformation occurs at the smaller values of pile stiffness for both MC and HS models. Maximum lateral wall deflection obtained using more Coulomb model, which is about 40.4% greater than that which we had obtained for the hardening soil model. And bending moment occurs for higher values of pre-stress force to a depth of around 10 meters, and then decreases with the increase in the pre-stress force. And as the depth of the excavation increases, then the horizontal ground deformation is going to increase to a certain maximum value, then it is going to decrease. So these are some conclusions have been made, and these are some different retention systems: second pile, tangent pile, cantilever wall, soil mix wall, coffer dams, contiguous pile. Also, one can actually go more deeper into these analysis, and we can do some deep excavation analysis on these solutions also. So thank you so much. These are some references. Thank you so much, Ramesh sir and Mahendra sir and Reddy sir, for giving me this opportunity to present two of my papers of my students. Thank you so much.
Okay, thank you, Mr. Anand, Dr. Anand. Assessment of effect of deep excavation in the adjacent structures. I have one question.
Okay.
Suppose the adjacent structure is having a foundation of about 1.8 meters. It is about 23 stories, and about 30 meters away from that structure. And if you are going for deep excavation of 45 feet, okay,
Yes, sir.
what are the precaution measures one should take to avoid?
So for that, first thing is we need to do the actually the stress distribution analysis for that particular foundation, the depth which we said, and from that we need to calculate the earth pressure which is going to act on the
So that is
on.
okay. What are the precaution measures to be taken?
So precaution measures, maybe we can go for diaphragm walls or maybe second pile wall or the contiguous pile wall.
What are
So
the precaution
where
measures?
yes, sir. Hello. So we can actually try for diaphragm wall, or maybe second pile wall or the contiguous pile wall, where we have, as I said, the foundation depth is very high and the significant structure is going to come G plus 30 as I said. So we need to have the very stiff structure like diaphragm wall.
Okay,
Where we can,
I'll interact you later.
yes, sir. Okay, sir. Okay, sir.
Thank you.
Thank you, sir. Thank you, sir.
Okay, thank you. Thank you very much. And 1320, thank you, Anand. Thank you. Yeah, thank you. Thank you. 1320 is there. Hazard assessment of 4 mines under impact loads using Almquist Johnson Cook constitutive model. 1320, I think, is not reported in the chart box. So I think that is not there. Now, go to the next paper, 1321. Performance evaluation of controlled blasting and prediction of alternate relation for cornucopia rocks by Nitish Yan, Padmanabhan G, Sudeepa Sri Rao BC. Please present your paper. It takes 6 minutes.
Okay, sir. Am I audible?
Yeah, you are audible. Right, you can proceed.
Yeah. Please continue.
Is my slides visible, sir?
Yeah, now it's visible.
Okay.
Yeah.
So, sir, this is regarding a work which we have carried out in a nuclear project. So the topic is performance evaluation of controlled blasting and prediction of attenuation relation for Charnocate rocks. So I'll jump into the presentation right away. This is the outline. First, we'll have a short introduction on why the rock excavation needs to be carried out and what are the methods which are available, what method we have adopted in the nuclear project, what are its parameters, and the outcome of the study. So here, even though rock excavation has been carried out for various purposes, why in nuclear projects and dams like that important structures, it has to be founded on the competent rock strata. Purpose is, of course, required bearing capacity has to come, and the rock strata has to perform with all forms of structural integrity at the time of earthquake event also. And to reach up to that level, that founding strata, if you see, it may be of the range of 25 meters to 30 meters. So to reach up to that level, first we can remove the earth using excavators. Further, rocks has to be removed through different methods. And the most adopted method in India is blasting with explosive. In that itself, controlled blasting is there. There are certain factors which needs to be controlled for rock excavation. So the factors I have listed here, but the course of presentation I'll be presenting mainly on the blast-induced ground vibration, how we can control that. As we know that once vibration is increasing, these nuclear projects adjacent itself, there may be other important structures like other running power plants. So whatever the blasting in order to reach to the required founding strata shall not affect the functioning of those plants. So for this, there are certain limits. The parameter which is used is peak particle velocity. So this PPV limits are being specified. The actual study has been carried out by United States Bureau of Mines, and in India it has been adopted by DGMS, Directorate General for Mines Safety, on a conservative plank from this study from USPM. Certain limits has been established. and these limits depends upon what are the type of adjacent structures and what is the blast wave vibration frequencies. One typical relation for PP presented. This is nothing but a function of charge. Charge means what is the explosive quantity. In other words, what is the energy that will be getting released, and the distance at which PP is measured from the source. And K and B are the site constants. SD we call it as scaling distance. I've already told us it as a function of charge and distance. Now the objective was first a limited blast work was carried out so that we can set a relation, have a first attenuation relation using which we can proceed further, fix the pattern of blasting, how much delay should happen. Delay means in one blast itself, it may be divided into some 12 holes will be there. 4 blasts will be blasted. After some 15 or 17 milliseconds, another 4 number of holes will be blasted. So a person who is hearing will be hearing only one single blast. Then the actual blasting has been carried out, extensive blasting for that area. Here, different attenuation relations are available in literature. So which one to be followed, which one will be the best suited, and also to obtain for that particular, I've already told certain site constants, K and B. This mainly depends upon the geology of that site. So to establish for typical geology, what relation to be followed, that has been our objective. So this is the attenuation relations which are available at in literature. In this one, the first two things are there. The first DGMS result, if you observe, it is inversely, the vibration is inversely proportional to the square of distance. Whereas in the Ambrosio hadron, the second one, it is cube to the distance. So from the trial blast study data, we have obtained the attenuation relation. What are the site constants? This for DGMS only I have presented. Similarly, we have done for Ambrosio hadron also. So in the DGMS relation, further after obtaining the best relation, we are further obtaining it for 95% confidence, so that we'll be having some factor safe. When the actual blast has been carried out, what we have observed is from trial blast, whatever the attenuation relation that we have obtained, putting the charge and obtaining the PPV, it has been underestimating the PPV. Actual blast, whatever the vibration that was coming, that was much more, some 30% to 40% more when compared to that of observed or that obtained from the attenuation relation from trial blast. So with the modified data or with the new data, further we have obtained what will be the attenuation relation. Similarly, for other relations available in the literature also, we have obtained the parameters. What we have assessed is the best correlation value is being observed for Ambrosio hadron, that is with the cube of distance rather than with square of distance. Of course, this study, this is a refined data. Actually, the data have only included the blasting being carried out and the responses being observed at a distance, and in between soil columns are present.
Please wind up.
Okay, sir. The correlation factors, it's not much different. So one more step we have assessed, which one is giving me the conservative estimate of the charge that is required to limit with the.
Please wind up. Time is up.
Okay. So as I've told, Ambrosio hadron is giving a better correlation, more conservative result. So we are planning to go ahead with similar geology for similar site for this nuclear projects with this relation as a inversely proportional to cube of distance. Thank you, sir.
Thank you. 1322 is not there, I think. Anybody is there? 1322. Geotechnical assessment of building damaged by tunneling works and suitable remedial measures. Anybody is there? Okay, next to 1324 reported in the chart box. Embedded retention wall design practices, consequences, and measures. It will be presented by Govindraj or Madan Kumar A. Who is there?
Yeah, I sir.
Please present and take 6 minutes.
Yeah, thank you.
Please wind up on time.
Yeah.
Running out of.
Can you see the screen?
No. Yeah, now we are seeing. Okay, it's visible.
Good afternoon, all.
Please start.
I'm Govindraj. Today I will be presenting the topic Embedded Retention Wall Design Practices,
Going that from which
Consequences.
institution?
Hello, I am from Kerala. I am the Geotechnical Manager for the Mumbai unit, North India.
Okay.
Yeah. So I will be presenting the topic Embedded Retention Wall Design Practices, Consequences and Measures. Here I will be going through the major issues which affect a retention wall design. We can club it into different categories like mistakes in the design practices. The second thing is parameters, certain parameters which affect the performance of the retaining wall. The third is trained and untrained analysis. So the commonly adopted design practices for the retention systems can be clubbed into three categories. One is the limit equilibrium method, second is the subgrade modulus method, and the third is the finite element method. The limit equilibrium, basically it's based on the linear earth pressures based on the limiting earth pressure coefficients. Whereas the subgrade reaction, in limit equilibrium, we are not talking anything about the soil structure interaction. Whereas in the subgrade modulus reaction, soil structure interaction is modeled to an extent. Here the wall is modeled like a beam and the ground as a series of horizontal springs. And in the finite element model method, again soil structure interaction is modeled and the computational domain is split into various smaller elements. So let us compare these three numbers, where the limit equilibrium method, it needs only ground strength, only the strength parameters matters. And there is no soil structure interaction. It will not give any structural deflections. Certain programs give some construction induced displacements, but still they are not the structural deflections. The next one is basically we can get a comparable result with the other methods like subgrade or finite element method for cantilever walls. But when it comes to the anchored or probed walls, basically there will be a considerable underestimation of the prop loads in limit equilibrium method, and there will be a lower value, a different value which we can find for the ultimate bending moments. Whereas the subgrade modulus method and the finite element methods more or less yield the similar results. So in order to establish this one, I took two examples. First one is a 7-meter cantilever wall, and the second one, case B, is in case B I considered 7-meter and 11-meter strutted wall. So I considered the Eurocode 7 and I considered the combination 2 of the Eurocode for the analysis. So here we can see in the first graph, you can see the cantilever case where there is only minor difference in the bending moment between the three methods. And whereas in the strutted case, I can see a variation of something like a 10 to 15% variation in the bending moment between the three approaches. Especially the limit equilibrium versus subgrade or finite element will yield a difference in bending moment of approximately 10 to 15. And whereas in prop loads, so this for the calculations again I use the combination 2 approach, ultimate load combinations. We can see a considerable difference in the prop loads, like 30 to 40%. There can be a variation in the prop loads if I go with the limit equilibrium method. So we have to be careful regarding the limit equilibrium when it comes to the when it comes to anchored or strutted walls. Now the second thing is a parametric study. We consider the effect of different things, different parameters like water table variations, over excavation, surcharge, soil stiffness, and wall flexibility on the retention wall. So we subdivided it into different categories like high impact, medium impact, and low impact. Here we can see that there is a very high impact on the groundwater variations or overdick methods on the retention wall. You can see the difference in the bending moments, whereas surcharge will have a medium impact. So this is another chart which is showing the variation of the factor of safeties on these three approaches. Again, high impact is there. Now coming to the soil stiffness variation and wall flexibility, they are basically having less impact on the bending moments, but at the same time, they have considerable impact on the deflections. But there will be very less impact on the bending moment and the embedment. Now the last thing, trained and untrained analysis. So again, I took the same example problem which I used for the first case A, but here I will just consider the service conditions. Here we can see that there is a difference in trained and untrained analysis. My embedment is going to increase in the trained. I have more bending moment and I will have more deflections. So generally, there is a very thumb rule to identify. Yeah. So we
Please
can
wind
go
up.
for a yeah. So the summary part is that for the cantilever walls, we will get a comparable result between the three approaches, whereas the anchored wall, the difference is high for prop and for probed wall. And there will be a considerable impact of water table variation and overtake on the retention wall behavior. Impact of surcharge will be minimum. But soil stiffness and wall flexibility are having less impact. So when we talk about long-term conditions, we should consider trained. So thanks.
Thank you very much, Govindraju. Next presenter will be on paper TH 1324, Embedded Retention Wall Design Practices, Consequences and Measures. That is over. 1326 now. Effect of overburden pressure and soil parameters of tunnel induced ground settlement by Chiranjeev Sarkar, then and Siba Priya Yam and Pichumani NK. Who is presenting? Yeah, Chiranjeev Sarkar. Please take 6 minutes. Yes, start your presentation. You are audible. Chiranjeev Sarkar.
Sir, please unmute.
Chiranjeev Sarkar, you please.
Yeah. Sir, is it visible to all my presentation?
Yeah. You can proceed.
Good afternoon, all. Today I am going to present my lecture on effect of overburden pressure and soil parameter on tunnel-induced ground settlement.
Please complete within 6 minutes. We are running out of time.
Okay, sir. So these are overview of the presentation. So introduction. Tunneling and underground structure are gaining popularity day by day in improving space congestion problem of the urban transportation network. It is essential to have an innovative, cost-effective and safe design of tunnel with appropriate consideration of design methodology and site constraint like existing building structure and other structure. Therefore, underground tunnel design require a proper estimation of ground settlement for safe, economically efficient construction of tunnel and underground structure. Variation in the ground settlement due to varying characteristics of subsoil deposit and tunnel depth, which causes the variation in the overburden pressure, need to address properly for the tunnel design. In present study, we cover a parametric study on 6.3 meter outer diameter typical circular tunnel having different depth of 9.7 meter, 10.6 meter, 12.8 meter and 13.6 meter, encountering varying soil layer of clay silt, sandy silt and silty sand. With different tunnel depth, the effect of various overburden pressures and difference in the soil parameter on the ground settlement has been logged to develop a correlation between ground settlement with tunnel depth and soil parameter. A set of numerical model in finite element method has been also developed to compare the result obtained from the analytical method as well as the field data recorded at the project site. So these are the few literatures has been referred during preparing my paper. So model of the study. A typical 6.3 meter diameter circular tunnel of DMRC Dwarka Najafgarh corridor has been considered for study and analysis. Depth-wise geotechnical parameter for tunnel stage within the project area is shown here. Tunnel depth of project area is varying from 9.7 meter to 13.6 meter below the ground level. Therefore, the surface settlement would vary due to the change in the tunnel depth as well as the change in the ground condition. Entire investigation part of the parametric study has been conducted in 12 different cases for 4 different tunnel depth, that is 9.7 meter, 10.6 meter, 12.8 meter and 13.6 meter with a different ground condition, that is loose to medium silty fine sand, medium to dense silty sand and very steep sandy clay sill. Two-dimensional numerical finite element method has been further developed in geotechnical phase 2 software for predicting ground settlement of the tunnel of depth of 9.7 meter. A model view of the geotechnical model is shown here for twin cross-section tunnel at depth 9.7 meter. Presentation of the results. Ground settlement value obtained from the empirical method for 12 different situations for 4 different tunnel depth with 3 different ground conditions has been tabulated below. Ground settlement from numerical model FEM for tunnel depth 9.7 meter is also shown below. Ground settlement result obtained from predictive method has been further cross-checked with realistic ground settlement data recorded at project site at Dwarka Najafgarh corridor. Ground settlement data recorded at the project site for similar ground condition with similar tunnel depth has been shown below. Similarity between the settlement behavior has been observed between these two results. Discussion on the result. There are 2 bullet points. First one is surface settlement for different tunnel depth with the same ground condition. Ground condition for 4 different tunnel depth has been plotted for 3 different ground condition are shown below. First left one, the comparison of the ground settlement for different tunnel depth at loose to medium sill defined sand ground condition. The right one, the comparison of the ground settlement for different tunnel depth as medium to dense ground condition. The above one, the comparison of ground settlement for different tunnel depth at steep, very steep sandy clay sill ground condition. Result from the above picture, it is clear that the ground settlement gradually decreases with the increase of the overburden pressure hereby the depth of the tunnel. It is observed from the shown figure that the ground settlement value decreases by 9%, 24% and 29% when the overburden pressure as well as the depth of the tunnel increases by 10%, 32% and 41% respectively, even when the ground condition remains same. The second bullet point is surface settlement for the same depth of tunnel with different ground condition. Ground settlement for 3 different ground condition has been plotted for 4 different tunnel depth. In the left hand side picture, comparison of the ground settlement for 9.7 meter tunnel depth at 3 different ground condition. In the right hand side picture, the comparison of the ground settlement for 10.6 meter tunnel depth for 3 different ground condition. In the left above side picture is showing the comparison of the ground settlement for 12.8 meter tunnel depth at different ground condition. In the right hand side picture showing the comparison of the ground settlement for 13.6 meter tunnel depth at 3 different ground condition. Result from the above shown figure, it is observed that the ground settlement values decrease by 14% when the ground condition change from the state of the loose to medium silty fine sand to the state of the medium to dense silty sand, even at the same depth of the tunnel. Ground settlement value decreases by further 25% even the ground condition change from the state of the medium to dense silty sand to the very steep sandy clay sill, even at the same depth of the tunnel. Conclusion. Ground settlement result obtained from the numerical model is very close to the actual ground settlement data recorded at the project site. Hence, it can be concluded that the numerical models give more reliable result among the all predictive method obtaining for surface settlement. Ground settlement vary with the variation of the subsurface deposit and the various depth of the tunnel. A shallow depth of the tunnel tends to have a relatively greater effect of the ground settlement than the deeper one. Ground settlement decreases with the change in the soil layer from the silty sand to the clay sill. Ground settlement gradually decreases with the increase of the overburden pressure, that is the depth of the tunnel. Ground settlement value reduced by 9 to 29% when the overburden pressure as well as the depth of the tunnel increased by the 10 to 41% even at the same ground condition. With the change of the ground condition from the silty sand to the clay sill, the ground settlement reduced significantly by 14 to 25% even at the depth of the tunnel remains same. So acknowledgement, author acknowledged the support from the entire team involved in the DMRC Dwarka Najafgarh corridor. Thank you.
Thank you.
Thank you.
Thank you. Thank you. Thank you. Hello?
Hello, sir.
Next presenter, paper number 1328, development of software for real-time instruments, monitoring and interpretation of tunnels and other civil engineering sectors by Heman M. Chaitanya G. and Mallika M. Please present your paper quickly. Heman, please take 6 minutes. Restrict your presentation to 6 minutes. We are running out of time.
Yeah. Good afternoon, everyone. I hope you can see my screen.
Yeah, you can able to
Yeah.
see.
So the pa- the paper which we am going to present here is that the development of software for real-time instrumentation and monitoring for tunnels and other structures. So the contents will be like we emphasize the need for this development and what exactly we have developed. So first of all, I'll briefly go through the need for instrumentation for any structure, let it be tunnels or any civil engineering structure. Various factors we understand more from instrumentation is safety. We get warnings, we get impending failures, indications. We need to evaluate our critical design assumptions, controls, better controls, remedial measures, and regular. These instrumentation and monitoring also help us to fight against litigations, and there are certain additional advantages, but I'll, because of short of time, I'll come to the subject of the topic, which is look for any tunnel. The monitoring nowadays, most of the tunnels are being designed by netum method, and hence we monitor convergences, we record convergences, we monitor the deformations by installing mpbx to understand the deformations which are happening behind the rock mass, which are not able to be seen from the eyes. And we install stress and strain meters, and this way we design as we go, the basic concepts of netum. But there are certain challenges on what we do, like we install all the instruments and we just keep on recording the data, but these data are just numbers. These numbers are recorded by the engineers at site. They are sent to their head office. They put them in Excel, or maybe if data logger is installed, they record the data. Then these are further sent to the consultant's office to analyze. And by the time things got analyzed, the site has already progressed 25-30 meters. So practically, this is in itself defeating the very purpose and very concept of Netum tunnel design. So to overcome that, these are other disadvantages of current system, like time lag. I have already discussed with you. Then these monitoring are expensive, because some person, a team is engaged in taking the reading, another team is engaged in putting in Excel and doing some calculations. Most of the consultant nowadays are doing on Excel only. Then much more manpower is required, and after a certain period of time, the data is so much that practically meaningful interpretation is really difficult. So finding a way out, we developed a real-time monitoring software which has got certain features. First is that software has got control levels, so we can give different control levels to different users: admin control level, user control level, and guest control level. The admin control level will have all the powers. For example, the user can just see the data but cannot alter it. User can see the data and alter the data respected in respect to certain particular area. For example, there are three tunnels. All the three tunnels are under different in charges, and there's a combined in charge for all the three tunnels. So the combined in charge can be admin, who can see all the data of all the three tunnels and do anything plus minus in that. The user will be the in charge of every tunnel, who can put the data and also see the data. And guests may be the contractor's representative, who are authorized only to see the data, but they cannot do any plus and minus in that data. The other advantage is that these software which we have developed will have immediate, will have the views and photos of the project site in the software itself. So visualization will be very helpful. The sampling rate we can control at any frequency. We can even do a frequency of once in a year or once 100 times in a second. So we can control it, and it helps in on-site visualization, and graphs and tables can be generated automatically. This I'll show you more with the help of these figures. Okay. These are all the instruments which we can connect with our data log, our ARMS real-time monitoring software system, right? For example, this is any tunnel, right? We from these are the buildings nearby the structures. Then the data will automatically give the color coding to the different structures considering the health state. For example, the red will be an alarm level, right? If any structure is reaching that particular, if any deformation value is reaching that particular limit which we have predefined, there is no need that that data should go to the consultant for its analysis. It will automatically give a different color to it. Similarly, it can give the colors on green and other, depending on different alarms, alert, alarm, and action levels we set. So this is the another key feature which we have inbuilt it in our software. We can have this on-site visualization like kind of system. It will be a board. which will be pre-programmed, and the light will glow red or green depending on the status of any reading. And once the light grows red, the
Please
hooter
wind up.
will, yeah, and the people can go out. So that reports and the data can be generated automatically. And basically, the idea of developing this software which we have developed is to make a meaningful interpretation of really installed instruments. Otherwise, it is just a set of data which we are collecting. Thank you.
Okay, thank you very much. Next presenter, paper number 1330, seismic analysis of shallow tunnels in soil medium by Ansari Abdullah, Rao KS and Jain AK. Please start your presentation.
I request last presenter to unshare his presentation first. Then I will be only able to present.
Yeah, I'm doing it.
Yeah, thank you very much.
Yes, please go ahead. Don't waste the time.
Yeah, my screen is visible or not?
No, not
You can find the present now option on the bottom right side of your screen.
present now.
Yes,
Go to
sir.
present now.
I got it. Yeah. Yeah, I think it is visible to you all people.
Please finish.
You can proceed.
Yeah. Myself Ansari Abdullah, PhD scholar at IIT Delhi, working with Professor K.S. Rao and A.K. Jain. Every day we are listening the news related to earthquake and earthquake hazards. Few days ago we have the news of Delhi earthquake, or I can say Delhi NCR. This is the topic related to tunnels and seismically active areas. So it is a combined one, seismic analysis of shallow tunnels in soil medium. This is the overflow of my presentation, introduction, deformation in tunnels due to seismic loading, study area and results, and finally I will make some conclusion based on our present research. If we talk about earthquakes, so there are many post effects of earthquake in the form of ground shaking, landslide, tsunami, building collapse, etc. But if we talk about underground structures, so these are the few pictures that you can see from the past earthquakes. This is the effect of 1995 Kobe earthquake on Daiki station in Japan. So you can clearly see how the column get collapsed of this underground metro station. So below picture is from China, 2008 Wenchuan earthquake in China. So you can see how the tunnel portals get collapsed here. So before handling the tunnel problem, there are a few things that we need to consider. The major seismic design problems are like tunnels crossing active faults in tunnel portals and poor geological condition. Poor geological condition can be handled before starting the construction. And tunnel portals are considered as a red zone for any seismic design of tunnels, or I can say underground structures. So how the tunnel or underground structure will respond to any seismic motion. So basically there are three types of deformation. One is the axial extension and compression. Another is your longitudinal bending, and the last one is ovaling deformation and racking deformation. So axial deformation is occurred when the seismic waves produce or motions parallel to the axis of the tunnel, while the bending deformation is caused by the components of seismic waves producing particle motion perpendicular to the longitudinal axis, while the ovaling deformation and racking deformation is developed when shear wave propagate normal, or I can say nearly normal, to the tunnel axis. So for circular tunnel, we can observe this ovaling deformation, and in case of rectangular, we can observe this racking deformation. So before heading for the analytical investigation for seismic design of the tunnels, we need to follow this procedure of a seismic environment. We need to handle the problems of seismic hazard assessment, ground hazard assessment, and geophysical testing. Now, we are mostly concerned on the analytical methods here. There are two types of method: free field deformation, and another is your soil structure interaction. In case of free field deformation, ground strain is caused by seismic waves, but we are interested in here soil structure interaction. So there are two types of soil structure interaction. One is the full slip and another is no slip. We consider two methods given by Wang 1993 and another is Penzian 2000. So as per the Wang 1993, they consider two conditions, both full slip condition as well as no slip condition. Here you can see the equations given by them. Here K1 represent the full slip lining response coefficient, while K2 is the full slip lining response coefficient for no slip condition. Now, these are the equations given by Penzian 2000 for both the cases, full slip as well as no slip. Here we can see that full slip assumptions under simple shear may cause significant underestimation of the maximum thrust, while no slip assumptions of the complete soil continuity be made in assessing the lining thrust response. And in case if we compare both method Wang and Penzian, we get unrealistic results, that is the low value of the maximum thrust in case of no slip condition for this Penzian 2000 meter. So it is recommended to go with Wang 1993 method. So we are focusing on Jammu and Kashmir region, especially Jammu division, including districts like Jammu, Udhampur, Riyasi, Ramban, etc. So major infrastructure project is going there, including Pir Panjal Tunnel, Chinani Nashi Tunnel. So presently we are working on USBRL project, Udhampur, Srinagar, Baramulla rail link. So this is passing through the Katra Banihal also, so there a tunnel construction is going. So we considered a tunnel in this Jammu division, which was zone 4. We consider these parameters including soil parameter and earthquake parameter. Quickly I am jumping for the results. So these are the results that we derived from both the methods, Wang method as well as Penzian method. So what we conclude that it can be observed that magnitude of error which increases with increasing the soil stiffness for both the methods having flexibility ratio less than 20, or error would be like less than 6% for soft soil to hard soil. So we consider different models S1 to S2 ranging between very soft clay to hard dense sand. So this is the variation of these deformation parameters, maximum thrust, moment and shear force with respect to flexibility ratio. Now we will jump for the conclusion. So tunnel constructed in seismically active areas subjected to dynamic loading in terms of seismic forces, and this will go under deformation. Yeah, and we did this sensitivity analysis which suggested that the soil stiffness has direct effect on the magnitude of error between these two methods. And for hard soils, we are getting conservative results. So analytical solutions are not so useful to estimate shear strain distribution, due to which maximum shear strain can be evaluated based on real-time seismic history. Yeah. So for the safe design of the tunnel lining, when tunnels are subjected to any earthquake or seismic activity, stress distribution must be considered for the analysis and design. So these are few references. Thank you very much, sir, for giving me a chance to present our research through this IDC 2020. Thank you so much, sir.
Thank you. Anybody is there? Paper number 32, development of rational method of design of soil draining system in granular soil
Yes.
point.
Yes, sir, I am here.
You are not reported in the. Anyway, please start your presentation and take 6 minutes.
Okay, sir.
Please.
Screen share. Good evening, everyone. I am Nagalakshmi, and now I am here to present my topic titled Development of Rational Method of Design of Soil Lining System in Granular Soils under the guidance of Professor C.N.V. Satyanarayan Reddy, Andhra University. Let's have a brief introduction of the topic. Generally, soil lining is being extensively used nowadays for stabilizing slopes and also for supporting the vertical cuts. But this method is adopted over other methods because of easier installation. And also this involves the installation of driven or grouted knives spaced closely down the slope in such a way that create an inherent coherent gravity structure to increase the shear strength and also restrain the momentum. And the nail walls derives their resistance from the soil and interaction, and the potential failure surfaces include pull-out failure, tension, shear, bending, facing failures, and of these pull-out and tension failures are the major criteria. And the forces acting on the critical slip surface are to be computed for assessing the soil nail wall safety. And these critical slip surfaces are either they may be circular or may be wedge failure based on the type of the soil. And these can be slip circle and both circular and two-part wedge mechanism or similar for soils with little cohesion, and for soils with medium or high cohesion we can go for circular slip surfaces. And different methods, either graphical and analytical methods are available for designing these soil nails. But with increase in use of these nails, there is a need for simplified methods. And the soil nail walls behave in such a way that the potential failure surface will always be in the range of 0.3 to 0.4 H at the top, and this is somehow similar to the failure surface of the reinforced earth wall. Hence, in the present study, the concept of reinforced earth is being used for designing the nail walls. And in the present study, nail walls of heights 4.5 to 10 meters are designed using the gasless methods. And also these are compared with the details obtained from the proposed method based on the coherent gravity. And the methodologies adopted here are gasless method. In the gasless method, for given geometry and the soil properties, the soil nail walls are designed for L/H ratios of 0.6. And the details, design values obtained from the gasless charts are also being compared with the details obtained from the polygon of forces acting on the critical wedge. And the proposed method, second one is the proposed method, which is based on the coherent gravity. And since the soil nail wall is behaving somehow similar to the reinforced earth wall, the concept of coherent gravity method used for designing the internal stability of the reinforced earth wall is being used here. The soil nail walls requires a minimum cohesion of 7 kN per meter square in order to ensure local stability till the facing is placed. So the presence of this cohesion affect the earth pressure, and hence the earth pressure used in this design is calculated based on the equation given by the wells. And these are the failure mechanism, the equations for tension and the pull-out failure mechanisms given in coherent gravity method as so. And since the soil is having certain minimum cohesion, so this is being involved in the induced calculation of induced tensile forces, and the equation is as shown here. And the FSWA is recommending the factors of safety of 2 against pull-out failure and 1.8 against tension failure. So these are being considered for our design, and these are the properties of the soil which are being adopted for designing the nail walls. And these are the details of the gasless method. The nail walls of heights 4.5, 6, 8 and 10 meters are being designed with driven nails of diameter 25 mm and grade of steel 415 with inclination of nail 10 degrees with the horizontal, and a slope of 10 degree with the vertical is being considered with the horizontal and vertical spacings of 0.5 meters. And the tensile forces are also being calculated using the polygon of forces. And again, based on the proposed methodology, here the walls are designed for the same heights and with the same die of nails by adopting a factor of safety of 2 against the pull-out failure is being considered here, such that we can observe a change in length of the nails. Here in this design we have seen an increase in the length of the nails. So based on this study, the following conclusions are being adopted. The geometry of the nail walls obtained from the gasless methods is not sufficient to mobilize the pull-out resistance, enough pull-out resistance such that we can have a factor of safety of 2 against pull-out failure. And also the gasless method considers Coulomb's earth pressure, whereas the Rankine's earth pressure is more appreciable in these type of walls. And also for a given soil, the length of nail obtained from the proposed methodology based on coherent gravity method varies in between 0.75 to 1.2 H for different heights of the soil, whereas it varies in between 0.6 to 0.7 in conventional methods. And also it is observed that the L/H ratio decreases with increase in the height of the nail walls. Of course, these driven nails are not preferred for supporting the permanent structures due to their lower mobilization of the cloud resistance. These are the references considered for the study. Thank you for giving me this opportunity. Thanks.
Thank you. Thank you. The next presenter, 1334, numerical analysis on interaction of single file tunnel system by Arnab C. and Avdesh Kumar C. Is
Yes,
there?
sir, I'm here. Yeah.
Please start your presentation quickly.
Okay, sir.
Restrict your presentation to maximum of 6 minutes.
Sir, is it visible? Hello? Hello?
I think Arnab has some problem. Let us go to the next one.
You can log out and log in again. Then
That can be done. Meanwhile,
the next
Once start presenting your screen.
Yeah, next is I think Supriyo Chaudhary and Indrani.
Actually, sir, my presentation, my audio is not coming, sir.
Yeah, just you just log out and again log in.
Okay, sir.
Meantime, next presenter, 1336 is not there. We'll go 1336 is the electrical resistivity testing and tunnel alignment under Lonavala Lake, a part of Mumbai Pune Expressway missing link project, a case study. Anybody is there? Okay, 1339 already reported in the chat box. Behavior of underground tunnel under strong ground motion by...
Sir, can I try now?
No, Irfan, you try next one.
Okay.
So by 1339, you please start presenting. Behavior of underground tunnel under strong ground motion by Irfan AS and Mohammad Zaid. Please start your presentation. 1339.
Sir, I think both of them, 39 is also not available, sir.
Is there reported actually? Okay, then Arnab, you please continue your presentation then.
Okay, sir.
Arnav, you can start presenting.
Hello, Arnav, don't use presentation audio.
Yeah. Now it is. Don't select. Yes.
Sir, it is shown that administrator muted your sound.
No, actually, don't select the presentation audio. Please click on the presentation now. Present now option now.
Yes, sir. I present now. I did. After that, sir, the entire screen.
Yeah, please click on present now option.
Yes, sir. I did.
You can't see your screen.
If it is not working, Arnab, you can send your PPT to someone here, to Mr. Vinil, and then you can just speak and he can present.
Okay, sir.
Okay.
You can set to
sir. You can, I think, take the next one for the time being.
1339 is also not there. 1336 is not there.
Okay.
So session is over, sir. Only is.
Okay, let us try. Let us try to listen to
Only
him.
Arnab. Last person.
Yes, sir. Sir, I will send anyone.
Arnab, can you just go at bottom, present now, just click that.
Yes, sir, I am doing that. Everything is coming, but it is showing that you are muted only.
Really?
Yes, sir. Actually, now he is not muted, sir. Arnab, please once try it. Yes.
Yeah, it's coming. Okay.
Sir, it is coming?
Yes, you can see it.
Okay, sir. Good evening, everyone. Today I am going to present numerical analysis on interaction of single file tunnel system. I will go through these contents in this presentation. With rapid urbanization and
screen is not coming. Only your voice.
Presentation audio select presentation audio select
Sir, screen is not going.
The audio.
Our audio is okay, but screen.
Sir, it is visible.
No, it's not.
Okay, sir. Just 1 minute, sir. I will try again.
No, at bottom.
Yes, sir. I am going through that only.
Now your voice is okay. Earlier voice disturbance was there.
Work. Send your PPT to Mr. Vinil.
Arnab, we will get in touch with you. No problem. We will send you the mail ID.
PPT, and then you can present the PPT. He can.
Sir, it is coming now?
Yeah, it's coming now.
Okay, sir.
Now restrict it to 6 minutes.
Right. 1 minute. Just. Okay, sir. So now I am starting.
Yeah, it's okay.
Okay, sir. Sir, today I am going to present numerical analysis on interaction of single file tunnel system. I will go through these points. With rapid urbanization and economical development, daily commuters are increasing rapidly in metropolitan cities. But the scarcity of the land holder puts a hold on the new road expansion or road construction. In this scenario, tunnel construction came out as a best solution for this problem. But whenever tunnel is constructed, the ground stress relaxation takes place, and due to this stress relaxation, ground settlement takes place. You can see this is the figure of Chennai. This Chennai road depression takes place due to underground metro tunnel construction. And this is not only the case of roads. When the stress relaxation takes place and the ground motion takes place, it actually affects of the foundation of nearby buildings of the roadways. You can see this is the figure of lots of buildings. It is affected in China. They are last year 2019 they are constructing one subway tunnel. Got this lot of buildings were affected and they are demolishing this. So these things, this tunnel pile interaction is now very important topic for this problem solution purpose. I have gone through this literature, and from this literature I concluded few points that if the tunnel and the pile distance between these two is less than the diameter of the tunnel, it will definitely give a detrimental effect on the pile behavior. Second thing is that if this whatever is that this all thing, the tunnel pile interaction mainly depends on the tunnel position with respect to pile. And third thing is that very few research only done on case of sandy soil. So that's why I did my MTech projects on tunnel pile interaction in case of sandy soil. I analyze all the things in two positions. Tunnel pile interaction when the tunnel placed in the mid depth of the pile and the bottom of the pile. And the last I did a parameter study to know what is the influence of the stiffness of stiffness of soil on this tunnel pile interaction. I considered FLAC software, FLAC 2D software for this purpose. So FLAC is a finite evidence software, and this is a 50-50 model. I considered 50-50 model with when we are increasing this size, it is not giving any effect on the results. You can see that there is a pile of length 10 meter and the tunnel has the diameter of the 3 meter. Its depth from the top is the 5 meter. In case of soil model, I consider elastic, perfectly plastic molecular model, and the pile model and the liner model is already pre-designed in case of FLAC, and the shear and normal coupling springs are used in this case. In the FLAC, it is used for the soil structure interaction. In case of liner model, it is a ductile and brittle. In this FLAC, liner model also can use like a ductile material, also brittle materials. So for validation of the numerical method, I used Malhotra et al. 2019 papers, and I keep all the dimension, all the data same on the property same, and it is showing the good agreement in between the experimental and the numerical results. And I started from the greenfield condition. Greenfield condition, it is shown that maximum ground settlements takes place at the center of the tunnel, and it is showing that it is decreasing with the increasing horizontal distance from the tunnel. So this is also an important point that it is meeting with the Gaussian distribution curve. It is observed that this tunnel, due to this ground settlement to the tunnel, is obeying this Gaussian distribution curve. The second thing is I consider these 2 points. One is the near the pile mid depth and near the pile toe. And what is the load carrying capacity change? And it is so that without tunnel and with tunnel it is decreasing 3.07%. But now it is the point why it is decreasing. You can see that this is the displacement. This is the displacement contour. From the displacement contour, one side is totally distorted. The distortion is done due to this. This is happening due to this tunnel construction. One side of the pile load carrying capacity is got badly affected. That's why it is decreasing. And in case of when it is the tunnel is placed in near the toe, it is 6.92%. It is more. So why it is coming? Why it is more? In this case, it is not only the decreasing the pile skin friction, it is also decreasing the point load. So it is combined effect of this. That's why it is giving the more decrement. You can say this is the load displacement profile of this pile without a tunnel. So from here we can conclude that this, in case of toe, when the tunnel will be in the toe, then maximum load carrying capacity will decrease. This is the parametric study I did for EP by EP for stiffness of the soil. It is shown that when the stiffness is decreasing, decreasing means EP by ES ratio, it is increasing means stiffness is decreasing. Then this reduction of the pile bearing capacity is also increasing very rapidly. So we can say that when the stiffness will decrease, then this pile interaction, this will be greatly affected. So it is increasing rapidly. So this is the conclusion. When the Gaussian distribution, it will obey, and maximum tunnel surface settlement is observed at the center of the tunnel, and it is reducing with the horizontal distance. In case of max Z2 by L by ratio 1 means when it is in the toe, it is giving the maximum maximum surface maximum reduction it is 6.92%, and this is also decreasing when it is the stiffness is decreasing. Then this interaction, the load carrying capacity of piles also decreasing rapidly with decreasing the sand stiffness. This is the observation I got from my study. Thank you, sir.
Thank you very much. I think all the papers are presented. 36 and 39 are there.
I think
39. Anybody is there? Okay.
I don't think so, sir.
Okay. Thank you very much. And quickly you can ask some questions on the papers presented. Any questions are there? We have not received any question in the chat box, but I had one question for Anand. It is Narsim Reddy Garu, just a question for Anand is there in the chat box. In my chat box it was deleted. There was a question.
Let me check. Yes, sir. To few questions.
Please ask that question. Let him answer. Anand, you can see that question?
It's not visible, sir. Yeah, those who ask that question, they can raise the question once again.
Reddy Garu, what is your phone number?
Sir, I just gave SMS to you.
You have my number?
Yeah, just I gave SMS to you. Just check it, sir.
SMS or WhatsApp?
Sir, I found that question. I have posted it in the chat.
Vinil, where is that question?
Someone posted question to Anand, sir.
Please read that question.
Have you performed any monitoring for surcharge pressure? If so, what type of instruments used?
Anand is here. Anand. Mr. Anand. Okay. Any other questions?
Chairman, sir, can I ask one?
Yeah, yes, sir.
Yeah, please.
Yeah, it is the very first presentation. I asked this question on the chat box also. If someone is there from there, I wanted to know how they got the modulus of deformation.
Yes, I am here, sir.
Yes.
The modulus, he didn't get modulus. That the modulus is a property that I get from the literature, sir. In literature, the modulus for both Moore-Coulomb and Hooke and Brown are available in literature, sir.
No. The question is, how did you? This was for the intact rock. For rock mass, how did you convert it to the modulus of rock mass?
Sir, my rock is a intact rock, homogeneous, sir. Intact and homogeneous.
Okay. It was not rock mass.
It's a rock mass only, sir.
So how you converted it from intact rock to rock mass? Or you got the values directly from the literature?
Yes, sir. I have already got the values from the literature, sir. All the values are from the literature only, sir.
And you use same values for Moore-Coulomb as well as for Hooke-Brown?
Yes, sir. Actually, he have tested for both Moore-Coulomb and Hooke and Brown properties separately, sir. Actually, the properties for Hooke and Brown and Moore-Coulomb he has found out, sir.
That's what I wanted to know. How did you find it out? Means, did you? What was the method did you use?
Sir, I can't hear, sir. What, sir?
How did you get those modulus values? Means, can you just explain? Means, what was available in the literature, and from there?
Yes, sir. Through the test, sir, uniaxial compressive test.
Yeah, that you might have done on intact sample.
Yes, sir.
But then you have to convert it into the rock mass.
Yes, sir. He have used rock mass lab. One separate software is there, sir, for determining the modulus value. He have used the RockMoss Labs software. With the help of that, he determined these Young's modulus and all the other properties.
Okay, okay. Okay, sir. Okay, Chairman, sir.
Thank you, sir. Thank you, sir.
Any other questions?
I think if there are no questions, thank you very much for all the presenters, and I request co-chair Professor Nasimha Reddy Garu to just briefly
Okay,
sum
thank
up
you.
the.
So yeah, out of I think 17 papers, about 13 were presented the papers, and in that, so mostly on deep excavations and few on tunnels, and one paper is on soil nailing, and one paper is also on instrumentation and its importance. Right. So this is the latest trend of going for deep excavations and in infrastructure, even tunnels. So they have done a good work, right? And I think the presentation also they could able to stick to their timings. So I would like to thank all the participants who have presented the papers. And yeah, this is my observation, sir.
Thank you, Professor Reddy. Of course, due to the horizontal growth is being restricted due to the increase in the land value. Nowadays, in the metropolitan cities, people are going for the deep excavation. In that respect, deep excavation is gaining a lot of importance, and it needs lot of research. I first of all congratulate IGC 2020 organizers for having allotted one theme on the deep excavations and also combined with the tunneling. I'm very much happy that all presenters have presented very well, and few papers having very good titles, they are not able to present. They had presented one case study on deep excavation would have been more interesting. However, all the presenters have presented very well, and myself and the co-chair will are thanking all of you on behalf of the organizers. And I thank our Professor Mahendra Singh for having maintained the session very well. And he was present 15 minutes early, and he was cautious about the time, and he guided us how to go ahead. Thank you very much, sir. And I thank the organizers.
I also
Yeah.
I thank the chairman and co-chairman. Means,
Yeah. I thank the organizers for having given us the opportunity to chair this session. And over to Professor Mahendra Singh.
yeah, thank you, sir, Professor Ramesh and Professor Reddy. It was very nicely conducted session, and as you already said, the topic is very very important, and we really enjoyed the session in the sense that there are so many things, new things, and there is a lot of interest in the papers. And especially when I compare, if I compare it with the physical conferences, I find that this particular conference is much more useful as far as imparting the knowledge is concerned. So, and it was very nice to have you people and all the presenters. With these words, I thank the chairman and co-chair on behalf of the organizing committee and on my behalf. So thank you very much. And now I hand over the session to the organizers. So chairman and co-chair, you are requested to do that duty, please.
Yeah. We will shut down.
And maybe Professor Reddy, if it is possible for you to write a paragraph about the session, that will be very nice. It was
Sure, sure.
about this particular session. So that will be we can hand it over to the organizer. So it will be a good thing.
Okay, I'll read. Okay.
And then other thing we will talk over phone. Please be available in another 5 minutes. Within 5 minutes, we'll finalize it, Professor Reddy.
Yes, sir. Okay. You can.
I will call.
I will thank.